Hey, how's it going? It's your bro here, and I hope your day is going well. And in this video series, I'm going to teach you guys C++ for free. I'm not here to try and sell you some course because I'm your bro and I have your back. My lessons are free, and they always will be. If you want to learn C++, look no further because you're in the right place. Let's get into it. If you wouldn't mind, please like, comment, and subscribe. One like equals one prayer for the YouTube algorithm. Let's begin by discussing the advantages of C++ over other programming languages. So C++ is a fast language. In fact, it is great for games, if not the best programming language for games because of its speed. So if you ever want to get into game development, I would highly recommend learning C++ at least at some point. Maybe not as your first language, but eventually you'll want to learn this. So C++ is also portable between different operating systems such as Windows, Mac, and Linux. C++ also supports object-oriented programming, and C++ jobs are in demand. Currently, at least in my geographical location, starting salaries for new C++ developers are starting at least at $60,000 per year, but that also depends on your geographical location as well. And if we talk about the advantages, we also need to discuss the disadvantages of C++ over other languages. So C++ is a difficult language to learn. I would not recommend it for your first language. Now, if you're watching this video and you're trying to decide on what you should learn for your very first programming language, I would recommend a few other things instead of C++, just because C++ is a more difficult language to learn. If you go to my channel, I actually have a few different playlists, and if you're undecided on what you want to learn, I would recommend starting with Python, just because I would say that it's the easiest programming language to learn compared to all the others. And other disadvantages of C++ is the use of pointers, and you'll learn what these are later. Misuse of them may make your system crash. There is no to little security with C++, and there is no garbage collection. But remember that all programming languages have certain advantages and disadvantages. The advantages, I would say, far outweigh the disadvantages. Well, what are the uses of C++? Well, I'm glad you asked. It's used for many popular applications, from web browsers to databases to desktop apps. It's because the language is so fast and efficient that any application that's requiring a lot of processing power, they actually better be using C++ because it's one of the fastest languages. C++ is also used for many game engines, and for example, it's used in Unreal Engine because of its speed. And it's also compatible with many embedded systems for electronic devices and microcontrollers. The C programming language might be better for this, but C++ also has the capability to be used for these embedded systems as well as an option. Now you're probably wondering, hey bro, what do I need to start programming in this language? Well, to answer your question, what I would recommend is downloading an IDE. That's an acronym for Integrated Development Environment. It's basically software that helps us write other software. And there's a few recommendations of mine. You just got to pick one of these. I would probably recommend Microsoft Visual Studio to begin. Otherwise, there's a package for Eclipse for C and C++ developers. Otherwise, there's CodeBlocks, but I think that's a little outdated now. But personally, I prefer Microsoft Visual Studio because you can also use it for C#, and there's some packages you can download for game development, which is pretty cool. So if you guys have no preference, I'll walk you guys through how to download Microsoft Visual Studio. If you have a different IDE in mind, feel free to use that one too. To begin, we need to open up the interwebs. Go to any web browser and double-click it to open up the interwebs. Good, step 1 is complete. Step 2 is to go to Google and look this up. Microsoft Visual Studio Code, and then you'll want to look up the community version. And it should be this link here, Visual Studio Community. And we're going to download Visual Studio. And we are going to close out of this because we do not like pop-up ads. And if you're running Windows, you have to open this when done. If you're using Mac, I believe you have to drag this to your applications folder. I'm not a Mac user, so I'm not 100% sure on that. We're going to click yes. And we're going to wait here a while. Click continue. and you're going to have to wait again. Well, you should be brought to a screen such as this one. Scroll down and click these two boxes, desktop development with C++, as well as Universal Windows Platform Development. Just so you know, there's other packages you can download as well. You can use Visual Studio Community for C#, Unity, and C++ game development. So keep those in mind. You can always select those two if you want. All right, then we're going to click Install. We don't feel like taking a survey right now, so we're going to click Not Now, and we'll continue waiting. Well, welcome back. We're just going to click this Launch button. Sign in with the Microsoft account, otherwise click Not Now, maybe later. All right, so with the development settings, you'll want to go to Visual C++. And then you can choose a color theme. The standard is blue, but if you want to feel like a pretend elite hacker, you can select dark mode. And for now, we will continue without code. Here at the home screen, we'll want to go to the top, File, New, Project. And we'll scroll down to C++ Console App. Click Next. We'll need a project name. Call this whatever you want. I'll call mine Hello YouTube. And you can set a location for your project. I'm going to set it to a folder on my desktop, or you can keep this as the default. It doesn't matter. And you can pick a solution name. A solution is basically like a grouping of projects. Here it says a container for one or more projects. You can just keep it the same if you want. And we're going to click Create. Now let me show you guys where you'd want to create a new C++ file. So go to your Solution Explorer, and for some reason if you don't have this window or you can't find it, let's just pretend that we close out of it. You'll want to go to the top toolbar, View, Solution Explorer, and you do have the option of moving this around if you prefer this in a different spot. And you'll want to go to Source Files, and there may or may not be a file here already. So this is like a test file, and it's actually right here behind our Solution Explorer, if I can move it. All right, yeah, so this is our test file, and all this does is that it displays the words Hello World, and you can actually run this just by clicking the screenplay button. And if you did have that file, a small console window that says Hello World should appear. However, you might have a different color scheme because I've changed this in past tutorials, but at the end of the video, I'll show you guys how we can actually change the color scheme for this as well. All right, so let's say that you don't have this file, helloyoutube.cpp or whatever else you name this. So let's just say that we delete this. So we'll remove it. Now to create a new file, go to Solution Explorer, Source Files, right click, Add, New Item, then click C++ File. Then next you'll need a name for this. I think I'll just call this main, that works. Then click Add. All right, let me shift some things around. Why is this so difficult? Okay, this should be good enough. So I zoomed in a little bit. If you want to zoom in on your code, you can go to the bottom left of the window and you can change it here. I think 250 is a good amount for this video at least. All right, so we have a blank C++ file. Let's create a program where we display text to the console window. Well, now you should have a blank C++ file if you want to create a program to display some text to that console window like we did before. This is what you're going to type at the top. A hashtag, like it's a Twitter hashtag. Type in the word include, less than sign, greater than sign, and within these two symbols type IO stream. What we just typed, this is a header file library. It lets us work with input and output. Next, hit enter to go down one or two lines, it doesn't matter. And then we're going to type int main, parentheses, then a set of curly brackets. So what this is the main method. So this is the entrance point to our program. And when we run the program, it's going to execute any code within the main method from the top, and it's going to work its way down. Now let's say that you want to display some output to the console window. This is what you type. Type in STD, and that is short for standard, and I'm not referring to sexually transmitted diseases. Then you need a set of colons, then type in cout, which is short for output. And when you combine these both together, it means standard output. Then next you need a set of less than signs. This passes information to our standard output to display to the console window. And then next, you can type in some text to display to that console window simply by putting it within a set of double quotes. So here you can type in the typical hello world, but I like to be different on this channel, and I'll type something else. So for your project, why don't you type in some lyrics to a song you like, and then post it in the comments down below because I would like to read it. So for one song that I like, I'm going to type in this. And then finish everything off with a semicolon. All right, let's run the program. Yep, and here are the lyrics. However, everything here is kind of compressed. You can actually add a new line to the end of this, so it gives you some more room. So we're going to go back to our code to do that. So if you want to add a new line, just type in \n, and that is a new line character. So let's rerun this. Here's the lyrics that we had before, plus it added a new line after our lyrics, which we intended. So if you're annoyed by having your code on a separate panel or window, you can just drag and drop these. So it's all like on the same window then, so it's a little bit more convenient to work with. All right, so next, let's say that you want to add a second line of text. Well, you just type in the same thing basically. So std, 2 colons, c out, 2 sets of less than signs, and then if you want to type in some words like lyrics, you just put it within a set of double quotes. So I'll type in the next line for this set of lyrics. And then we have the option of finishing this off with a new line. And then don't forget that semicolon at the end. All right, so let's run this. And here's the results. It says, never gonna give you up, never gonna let you down. So you can have multiple lines to display output if you so wish. And in the next video, we'll be discussing more on how we can display output. So before we wrap up this video, let me show you guys a few tricks that we can use to change the color scheme of the IDE, as well as the text and the color of the console window. So let's say that you don't like your current IDE color theme. Let's say that you don't like this dark theme. I don't know why you wouldn't. If you want to change it, go to Tools, Options, and then you can change it here. You could go to, let's say, blue, then hit OK, and this should change the color scheme. But that is very hard in the eyes, but some people might prefer this and they prefer to be blinded. But I'm going to go back to dark because I am a pretend elite hacker. If you want to zoom in or out of your code, you can change that here in the bottom left corner of your window. You can either pick one of these few settings or you can type in a number that you like. I think 250 for me is a good amount. So lastly, you can change the color scheme of the console window that displays, more specifically this one. I think the default is white text on black background. If you want to change that, actually I already changed mine, but if you want to change it, click the top left corner, then go to Properties, and then here you can change the font size, you can change the cursor size, the layout of the window size, the colors. Actually, let me pick a new font. That's close enough. All right. And then you can change the colors here. You could have like green on green background, which I would not recommend. I think I'll stick with the green text on black background. Oh, I guess you can also change the opacity. Ooh, that's kind of neat. Woo, woo, woo. And then just click OK with any of your changes. And you can see that I changed the font style slightly. So that's how you can change the appearance of your console window. So that will conclude this introduction to C++. In the next video, we will get more in depth with displaying output and eliminating some redundancies that we have here. I'll explain how that works in the next video, but I'll also include some useful links in the description down below. So if this video was very exhausting to make, feel free to smash that like button and drop a comment down below. Hey, what's going on everybody? It's your bro here, and in this video we're going to be discussing output and a few other miscellaneous features with C++. Let's get into it. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. First things first, I want to discuss with you guys the use of namespaces. In programming, we can't have variables, functions, and other things with the same name. So to avoid that from happening, we can use a namespace. Different namespaces allow us to reuse the same names for things as long as they are within a different namespace. We can reuse that same name in a different namespace. In our standard output, we are saying that we are using the standard namespace for our output, and it can be annoying to have to type std before every line, but there's a trick that we can use where we don't have to write this every time. So outside of your main method, this is what we're going to type. Type using namespace std. So this is telling the C++ compiler that just assume everything here is using this namespace, so we no longer have to type this out explicitly, and this will work just the same then. Next, let's discuss the return 0 statement that you might see at the end of a main method. So programs may calculate or process something and return a result. What you may see at the bottom of many functions in C++ is this return keyword, and they usually return some sort of value. At the bottom of your main function, we're going to want to return 0. And this isn't necessary, but I'll explain what this does in just a moment. So in C++, this is sometimes referred to as the exit status. What this does is that our program, if it runs fine without any errors, it will return 0. And this is like a success status, like saying the program ran fine with 0 errors. However, this is only required in C programs. It's optional in C++. The compiler automatically adds a return 0 if we don't explicitly write this, but in case you do see this, this is what this means. Let's move on to line breaks. When we write output statements, our output will only add a line break if we explicitly let the compiler know that we intend it to. So for example, let's remove these new line characters and see what happens when we run the program. So our output is all in one long run-on sentence. It's all on the same line, even though our code is in two different separate statements. So you have to let the compiler know that you intend to break this line and go down to the next line as if you're hitting enter. And there's actually two ways to do this. The first is that we covered it in the first lesson. You just use the new line character, and I'll get into this more in depth later on in this video. The other way is that we can add these two left angle brackets, and these are sometimes referred to as the insertion operator. They basically pass along data and then add end L, then semicolon, and this is short for end line, but make sure you take out that other semicolon. And this will work just the same then, so let's add that here as well. So this is another way of writing what we had before. Each has their own uses. Yeah, and you can see that each line has a line break and shifts down to the next line after it's finished. The second option to use a line break is to use \n, which is what we did previously, but I'll explain this more in detail. So the backslash portion is part of something called an escape sequence. Depending on what character that we add after the backslash, it will have a certain effect on our output. If we add \n, it will add a new line. And for example, if I add \n before each of these words, it's actually going to print each of these words on a new line. So let's try it out. Yeah, and you can see that changed our output. So you can use this escape sequence for a new line anywhere you want within here. And there's other escape sequences as well besides new line, like \t is for tab. So let's try that out. So this will add a tab before each word, and you can tab things and space things. If you need to write a set of quotes, like you're quoting something, you might have trouble because your program won't know where our string of characters begins and where our string of characters ends then. So you can use an escape sequence to add some quotes, which is \, and then single quote or double quote. So if you want to like quote something, like we're quoting lyrics to a song here, you could just add \, and then a set of double quotes. And let's try this out. And you can see that our first line is now within quotes as if we're quoting something. And for some reason, if you need to print out a \, you actually have to type double backslashes, and let's try that out. And here's our \. Because remember, if you have just a single \, the compiler thinks it's a beginning of an escape sequence. So if you need to print it out, you need double backslashes. So those are a few of the basic escape sequences that you should be aware of. There's still many more out there, and if you have time, I would suggest looking through online to see what else is out there, if there's any that would be relevant for you. But those are just a few of the basics before we really start to dive into programming with C++. Lastly, for this video, we are going to discuss comments. Comments are a portion of code that is ignored by the compiler. It's like a secret message, and it won't be displayed or processed. They're used to leave notes for yourself or for other people reviewing your code to read. It's like a secret message. Here's an example of us using a single line comment. So what you're going to need to do is to type in 2 forward slashes, and you can see on my screen that this text became a green color, and we can write a comment here. So perhaps for a comment, I'll write lyrics for a song that I enjoy. So if we were to run this program, it's not actually going to display this comment. And you can see that it skipped it. It's basically like a secret message for yourself or for somebody else that's looking over this code. So you can also write a multi-line comment. All text that you want to be included within a multi-line comment should begin with a forward slash followed by a asterisk, and you'll notice that all this text now became green because we're saying that we want all of this to become a comment, everything after these 2 characters. So you'll want to put a ending position for where you want this comment to end if it's on multiple lines. So let's say that we want our comment to end here. What we need to type is then asterisk and then a forward slash. So everything within here will be a comment, and we can add multiple lines to here. Like I can say something such as, these lyrics are actually very good. All right, so then let's run this. And all of this will be ignored. It's like a secret message that either I myself can read or other people can read. Well, that will conclude this topic on writing output, escape sequences, comments, and a few other things I forgot to discuss in the first lesson. So in the next lesson, I will be teaching you guys about variables. But yeah, that will conclude this topic on some of the fundamentals of C++. Hey, what's going on, everybody? It's your bro here, and in this video, we're going to be discussing variables in C++. Let's get into it. Do you guys remember in math class in school where there was an equation such as this, and you can solve for what the value of x is, and then you can reuse x as if it were that actual number? Like here, in our example, x equals 2, and then if we use this in another equation, x behaves as if it's the number 2, and we can produce a result. So for all intents and purposes, our variable here could store some sort of value, and it will behave as the value that it contains. And we can reuse those variables elsewhere in our C++ programs. However, we are not limited to only assigning numbers to variables. We can also assign words, single characters, or even these things called Boolean values, which hold either true or false. Heck, we can even assign entire sentences to a variable. Now, these are the steps to create a variable in C++. The first is that you need to come up with a name. Let's pick something simple to begin with, such as x, just because we're used to using x like in math class. We'll say x equals, and then we can give it a number if we wanted to. Let's say 2020, and then finish this with a semicolon. All right, so there's one more step that we need. We need to declare what type of value that this variable is going to hold. So there's certain rules that apply when declaring variables, and if this variable is going to store a value of some sort, we have to declare what type of value that is going to be stored within this variable. For example, this could be a whole integer, a decimal value, a single character, a string that's like a series of characters like a word, a Boolean value, etc. So for example, if we wanted to store a whole integer value, we would have to declare this of the int data type, which is short for integer. But there's other data types that we should cover. So let's discuss what those data types are. Now, before we really begin to discuss data types, these are only a few of the data types that are available to us. I'm only going to be covering a few of the basic ones just because they can get somewhat complex, but I want to give you just enough information to get started with using data types. And then as you understand how these work, you can look at other data types to see what would suit your needs. So to begin, let's discuss the integer data type. This will only store a whole number, An example would be an age or a year. Like you couldn't store a decimal value within here. Like you wouldn't say for like a year, you wouldn't say it's like the year 2020.5. I guess for an age though, if you're a young kid, you might say like I'm 7.5 years old, but typically people don't put like a decimal in their age. So if you want to declare a variable of the integer data type, you just write int before the variable name. A double will store a decimal. An example would be a price, and you just write double before the variable name. And the reason that this is named double, it has to do with double floating point precision. It relates to computer science, but think of double as a decimal. So you can store something such as a price, anything that contains a decimal portion. The character data type, sometimes referred to as char, like you're pronouncing Charizard, will hold a single character like a letter or a symbol. A string, that can hold one or more characters. An example would be somebody's name, or even an entire sentence or a paragraph. And this also has the capability of holding a single character, but we treat strings and characters differently. And we also have Boolean, which can hold either a true or false. And this is useful if you need to verify if something's correct or not, if something's on or off. And to declare something of the Boolean data type, you just write bool before the variable name. Now remember, these are only a few of the most commonly used data types that would be used for beginners. So there's definitely more out there, just so you're aware. But these are a few just to get us started. Let's head back to our program. Now, if we want to store a whole integer within a variable, we have to declare this of the integer data type. And according to that cheat sheet, we had to place int here for integer. Now, we can reuse this variable as if it was this number. We can actually display this if we really wanted to. We'll use our display method cout, and then we'll just place x here. Now, we don't need to put anything within double quotes because that will literally print something. So we can just reuse x, and then I'm forgetting that semicolon at the end. All right, let's display this. And here is our result, 2020. Now, when naming variables, it's important to name it something that will help you and other people identify what this is. The letter X isn't too descriptive. We can rename this something perhaps as year, and that's much more descriptive, and we will have to change it here as well. So you're not limited to just having a variable named X. You can name it other things too. Like year is more descriptive of what kind of value that this variable will contain. And this will work just the same as it did before, despite the name change. How about we create a couple more variables, and let's have them all be related to, how about cars? I like cars. So let's create a few variables based on the data types that we just learned about. So if we want a price, we can use a double value because that can hold a decimal. So we'll say double, and then we'll create a variable named price equals, and then we can assign a decimal value here. So $9,999.99 sounds pretty good to me. I'm thinking for our next variable, we can assign a char value, a single character, so we need to say char. And then how about a status, like is our car new or is it used? So we'll say status equals, and then if you're assigning a char value, you need to put it within single quotes. And you can put any one character in here, doesn't matter which one. So how about we say N for new, U for used. So that would work. We need a string still. So how about a model of a car? So we'll say string, and then model equals, and then if you're assigning a string, you need it within double quotes. So pay attention that with integers, you don't need any quotes. Same with doubles. For char values, you need single quotes. Strings, you need double quotes. So I'll pick my favorite car, which is a Mustang. And lastly, we could use a Boolean value. So we'll say bool, short for Boolean. And how about we create a variable named for sale? Like, is the car for sale? True or false? Yes or no? So we can say, true if it is, or false if it isn't, but I want this car to be for sale, so I'll say true. So there we go. We have successfully created 5 different variables, and now we can reuse these variables elsewhere in our program. And we can display these variables much like we did with the year. However, if we're going to be displaying multiple variables, we probably want to separate these by line. So actually, I'm going to add ENDL at the end of this, just so we can move each of these variables to the next line. So ENDL, then we'll say C out. How about status next? ENDL. Same process with model and for sale. All right, let's display this. All right, so pay attention for the Boolean value of for sale. It actually came up as a 1, and that means true. If it was 0, that means false. Now, when we display variables, we can also display these variables along with some text as well. So let's say that we want to make some sort of chart where we display all this information for a car. Well, the first step to do that is that we'll want to write a string of what we want to display. So let's say that we want to display the word year and not the variable, perhaps a colon and then a space, and then we'll display whatever value is within year. However, compared to other programming languages, you have to add like a plus here to display the variable. However, in C++, you need to use the insertion operator, so that's one thing that's different. And this should go away in a moment. Yep, okay, so that cleared up. So if you want to combine displaying variables and some text, you need to separate each of these with an insertion operator. So let's do the same with each of these variables here. So we'll say price, then use the insertion operator. So status, I believe that was new or used. So probably I'll put like new/used so it's more understandable. And this will just take a moment. So we'll say model, and then for sale. Actually, I think I'll say availability. I can never spell this word. Availability. That's probably wrong, but close enough. All right, so let's display this now. All right, so you can see that we displayed some text along with our variable for each of these lines, except I messed up spelling model and availability, so let me go and fix those, because it's actually going to bother me if I don't. Okay, that's a lot better. So we have like the year here, 2020. It's a price, $9,999, a new Mustang. Availability 1, which also means true, 0 means false. Now I'm going to take the next part of this video just to show you guys a few different tricks that we can do with variables. For example, we can reassign values later on in our program. Let's say that this car is no longer for sale. We can say for_sale, the name of this variable, now equals false. So when we display this, it's now going to show the updated value when it was last updated. So this should display 0 now. And take notice that I didn't have to declare what the data type of this variable is, because you only have to do that once. And if you declare this variable type once, you don't have to do it again. Also, it's possible to declare a variable and not assign it a value right away, in case like you want to assign it later. For example, we could just say for sale is going to be a Boolean variable, but we don't know what value we want to assign to it quite yet, so we can just declare a variable and not assign any value, and later on in our program, we can assign that value later on. One thing that you should be aware of when using variables that contain an integer or a decimal is that you can use these as if they were this number, and that means you can also use this for math functions. Let's say for our price, there's like a 10% discount. What we can do is we could say the price equals whatever this price currently is times 0.9. That would be the same as a 10% discount, and this price will actually be updated. So let's run this. And these are actually treated as numbers now. Like you can see, the new price is $8,999. Now with strings, you can also combine strings together. For example, let's say that we want a variable named make. So the make of this Mustang would be Ford. All right, so we have a make and a model. So we can also combine these together. So we could say perhaps string, how about car, equals make plus model. And let's display this car variable instead of model. So we could change this to car, and we will display the car variable now. So this should say Ford Mustang. All right, but see that it combined both of these words together and it doesn't have any space between them. So you also have to take that into account. So we could say make plus a space plus model equals car. And this would also be an option too if you want to do some separation. So it's kind of like our car, which is a string data type, is holding like a whole sentence now, it seems. So those are the fundamental uses of variables. They can store a value, but you have to list what data type they're storing, and they will behave as the value that they contain. And you can reuse these later on in your program for any purpose. And you can name these basically whatever you want, but there's a few keywords that are off limits. Now, please be aware that there are more data types than this. I went over only a few of the more basic ones, just so that we can get the hang of things. There's more if you look online. For example, with doubles, there's also these things called floats, which also hold decimal values. They're referred to as floating point numbers, but they use 32 bits of precision, whereas in doubles have double that precision, 64 bits of precision. And it's usually better to use doubles over floats because they are more accurate. So people tend to use doubles over floats. So if you guys are looking for some practice, I'll post the source code in the comments down below. And why don't you guys fill in some variables here of a car that you would like and post it in the comments down below. But yeah, that is everything you need to know to get started working with variables in C++. Hey, what's going on everybody? It's your bro here, and in this video I'm going to teach you guys how we can accept user input using C++. Let's get into it. Computer programs are usually a two-way street. They accept user input, they do something with that input, and they produce output. Not always, but most of the time. So up until now, we have only been displaying output without accepting any user input. But today, that's all going to change because I'll show you how. What we can do is that we can accept user input and store it within a variable that we can use later on in our program. So to begin, we'll want to create a variable, and for our example, let's create a string variable simply named name. So we'll say string name, and we don't necessarily need to assign this variable a value right away. We can simply just declare it without assigning it. So effectively, this variable will not contain any value until we enter in some user input, and that user input will be assigned to this variable later on in this program. So next, we'll want to create a cout statement that will function as a prompt to let the user know that we want them to enter in their name. So we'll use the cout statement, and let's create a prompt such as, please enter your name. All right, and this is what you do if you want to accept user input. You need to type cin for input, and next you need to use the extraction operator, which is 2 right angle brackets, and then you're going to put your variable here. So in our case, it's going to be name. So this is what you do to assign user input. Next, we can use this variable elsewhere in our program, so now we can display a message using another cout statement that includes our variable. So we can say, welcome, name. So let's try this out and see if it works. All right, so let's run this. So here's our prompt, please enter your name. So here I'm going to type in bro and hit enter, and it says, welcome bro, and that was our user input that we entered in. So going back to our code, I'd like to show you guys something. Now with the cout statement, you'll notice a pattern. We say cout for output, then we use the insertion operator, and then we write whatever we want to display as output. Then with input, we do something kind of like the opposite. We write C in for input, then we use the extraction operator, which is 2 right angle brackets instead of 2 left angle brackets, and then we write something to function as input. It's kind of like the C out and the C in statements are kind of opposites. We have C out and C in, output, input. We have the insertion operator, which is 2 left angle brackets, and the extraction operator, which is 2 right angle brackets. And then for C out, we have the output that we want, and for C in, the input that we want. So you're also not limited to only using strings as variables. For example, let's create an int, which is an integer, and we can change this to perhaps age. And we can say, please enter your age. And we will change name to age. And for our output, we'll say something such as, your age is whatever we enter in. All right, so let's try this out. It's going to be the same process, basically. Please enter your age. I'll just make up an age and say I'm 18. Hit enter, and it says your age is 18. So you can enter in whatever sort of data type that you need. So one problem that you may encounter in the beginning stages of your programming career is that if somebody enters in input that's not of the type that you anticipate, for example, for our prompt here, it says, please enter your age. And if I don't enter a number and put a word here, such as pizza, because that's the first thing that comes to mind, and hit enter, it's actually going to cause an unexpected result and sometimes cause an exception. So later on in a future lesson, we're going to cover exception handling, where we can prevent people from doing things such as this and take corrective actions. So in the meantime, you just have to be sure that you're entering in information that is of the correct data type that you're anticipating. All right, so there's another type of input function that you guys should be aware of, and I'll give you guys a scenario. So what I'm going to do is reverse all these changes back to when we entered in our name. All right, so let's run this, and I'll show you an example. All right, so let's say that we enter in a first name and a last name, and I'll just enter in a last name that I make up, like Bro Washington, and then I'll hit enter. All right, so you can see that it actually didn't enter in my last name. It wasn't stored within that name variable, because when we use this cin statement, it stops at any blank space. Cin considers any white spaces as terminating characters, so that means we can only use this to assign a single value or word without any white or empty spaces. So if we were to rerun this and we entered in this first name and last name all within one word, this would still work then, but any blank spaces are treated as terminating characters. So if you need to accept user input that will ignore spaces, there's a different form of user input that we need to use, and that is the getLine function that will read a line of text for us. So in order for us to use this getLine function, we need to include something at the top of our program. So we're going to, at the top, write include, then within a set of angle brackets, type in string. All right. So then what we'll do is we'll replace this cin statement with getLine, then a set of parentheses, and what we're going to type within here is first cin, comma, and then the name of the variable in which we want to store something, and then type a semicolon at the end. Then let's rerun this and see what our result is. So it says, please enter your name. So what if we typed in our full name? So Bro Washington. Hit enter, and it now displays our entire full name despite there being a blank space between the first name and the last name. So you can use this getLine function to read an entire line of text. And it really doesn't matter the length. I'll just type in something that's insanely long and hit enter. And you can see that it read this entire line of text up until we hit enter. Just so you're aware, you can't use the getLine function for any data type that is of the integer, float, or double data type. For example, if I were to change name to an integer data type, this would not work. But the same thing would also apply to a char value, I guess. It would only apply to string data types because it reads a line of text. And basically a string is one or more characters. It's basically like a line of text. You can think of it that way. So it's useful if you need to read a line of text that includes spaces. So that's the basics of accepting user input using C++. Now, if you're looking for practice or a project, what we're going to do is that we're going to create a program that's going to simulate a cash register where we can ring up an item and we'll actually accept user input. We'll ask the user what item they'd like to buy. We'll record a price. We'll have the user enter that in as well, a quantity, and then we'll generate like a final total or bill. So let's work on that program. Let's clear all this out and start over. All right, so if we want to write this program, we're going to want to declare all of our variables right away. So what we'll do is create a string, and we'll call this item. What item do we want the user to buy, or what item will they enter in? We'll want a price. This will be a double value, so that's basically a decimal value for a price. We'll need a quantity. That could be a integer value, so we'll say int quantity. And lastly, a double value, which will function as the total, which is the total amount that the user has to pay. All right, so first we'll want to create a prompt that will ask the user what item they want to buy. So let's create a prompt using the cout statement, and we'll say, what item do you want to buy? All right, then we need to use the getLine function for this because the user input might include a space if they're entering in an item name. So we'll say getLine, parentheses, we'll type cin, comma, then item because this is the item name. We're going to store the name of an item within here. All right, next we'll ask for a price. So we'll need another prompt. We'll say, what is the price for each? Then use whatever type of currency you want. I'll use American dollars. All right, and then we can use simply the cin statement for this. We don't need to use getLine. Cin price, and we can use the cin statement for double values. All right, so next we'll use the cout statement to ask for a quantity. How many do you want to buy? And then we'll use cin again and ask for the quantity, or store the quantity. I can't spell. All right, and then lastly, we need to generate what the total price is going to be. But first, I'm going to add a end line just to give us some space after generating the total bill. So I'll just say cout endl for end line. All right, so now what we can do to create the total is we can say total equals price times quantity. So, but make sure you spell it right. Now for the second part of this program, let's create a receipt that will display the results. So we'll type this after we calculate the total. So let's create a cout statement, and we'll write something such as item, or you can type in like item name, whatever you want. Doesn't matter too much what you type here. So we'll type in item, and let's add an end line keyword after this. And it's going to be a similar process for the other inputs that we have. So price, and then price. So you don't have to type these strings exactly the way that I do. This is just how I would create like some sort of bill or receipt, but you know, do whatever you want here. So perhaps for a quantity, I'll just put X for like a multiplier of some sort. Like you bought this at this price times however many you bought. So we'll say quantity here, then end line. All right, and then we will say cout. Your total is, then I'll just add the $sign or whatever currency you're using, you can add that here. Total, ENDL. right, it all looks good. Let's run this. All right, what item do you want to buy? Bag of chips. Potato chips. What is the price for each? How about $1.05? How many do you want to buy? I feel like 5 bags of potato chips. All right, item, bag of potato chips. Price, $1.05 times 5. Your total is $5.25. I forgot to add the $sign for the price, but it would still work regardless without it. I'm just very particular with small details like that for output. But yeah, that is some of the basics for accepting user input. If you would like a copy of this program, I'll post it as source code in the comments down below. So feel free to try this out for yourself. And if you practice with this or generate some output, post it in the comments down below as well, because I'd like to see what you came up with basically. Or if you'd like to create your own version of this, feel free to post that as well. But yeah, that is how to accept user input using C++. Hey, what's going on everybody? It's your bro here. And in this video, I'm going to teach you guys all about using arithmetic operators in C++. Let's get into it. Alright, well in this video, I'm going to be discussing 5 of the basic arithmetic operators that you'll see in C++, some rules regarding them, and some cool tricks that you can use. So just a fair warning that this topic is somewhat dull and boring, but I'm going to try my best to keep it fresh and interesting, and if you can make it through this lesson, I would say that every lesson after this is going to be more interesting. So let's begin. Let's go over the 5 basic arithmetic operators. The first is addition, and anytime you want to add something, you just use the plus symbol. Next we have subtraction, and you use a minus symbol. I know, we've covered this in grade school, many years ago, but there's a few other arithmetic operators that you should really be aware of. First is multiplication. And do you remember back in math class where you would use x to multiply something? For example, like 5 times 5 is 25, and you use x to multiply? Well, in programming, we use the asterisk symbol. So use this anytime you want to multiply something. Next, we have division. And you use a / anytime you want to divide something. And lastly, we have this thing called a modulus, and it's a percent sign. So the modulus is unique. Basically what it does is that if you divide 2 numbers, you have I believe it's called a dividend and a divisor, and you use the modulus between these two, and instead of giving you the quotient, it gives you the remainder. But don't fret right now if you don't quite understand what a modulus is. I'll give you an example of how it works and some practical applications of us using one. How about we go over an example of each of these? Sounds good, right? All right, let's get started. All right, so with addition, we could say something such as C out, and then this is an example of us using addition. We could say 5 plus perhaps 2, then semicolon, and this will just display the number 7. We're using C out to display whatever the result is, which is 7. So I'm going to comment this out and then just write this as an example. And when we're finished with this, I'll post this in the comments down below and pin it to the top if you would like a copy for notes or something. All right, so an example of us using subtraction, C out, then we need to use the insertion operator. Then we could say 5 minus 2, and then just display the result. And the result is going to be, obviously, 3. So let's turn that into a comment. All right, multiplication. We'll say C out, and then we could say 5 times 2. So remember, we don't use x for multiplication. We use the asterisk symbol for multiplication. And the result is going to be 10. So let's turn that into a comment. All right, so division. This is where it gets tricky. So C out, how about 5 divided by 2? So the answer should be 2.5, right? Well, that is actually not the case. The answer that we get is 2, and this is the reason why. It's this thing called integer division. So if you divide by a whole integer, or something of the integer data type, it's not going to record that decimal portion and it gets truncated. So if we have 5 divided by 2, the result is going to be, 2.5 obviously, but it can't handle that decimal portion, so it just drops it or eliminates it. And we're stuck with the result of 2, which is not correct, but the computer thinks it's correct. So one trick that you can do is that you can change this to a decimal value or a double value. So if we were to say 5 divided by 2.0, this will actually save the decimal portion, and we are ending up with the result of 2.5. So make sure you remember that, because when you first start writing programs, you might not notice that you're using integer division and you might get an unexpected result. So be sure that if you're dividing by a certain value, make sure that it's a double value or something with a decimal. And there's this concept called casting where you can convert from one data type to another, such as an integer to a double type. But for now, just make sure that if you're dividing and you want to keep the decimal portion for the result, make sure that you're dividing by a number with a decimal. All right, so let's turn that into a comment and move on to modulus. Oh, quick note, so I decided to just do a little bit of formatting with these comments. I also added the results for each of these operations for our examples, just so you can have some notes to look at. And remember that I'll post this in the comments down below. Okay, so the modulus. The modulus works exactly like division, except instead of giving you a quotient as an answer, it's going to give you the remainder. For example, if we said cout 5 modulus 2, instead of displaying 2 or 2.5 if this is a decimal value or double value, it's actually going to display the remainder. So 5 does not divide by 2 evenly with integer division, so it's going to give us a remainder of 1. And this is actually useful if you need to determine if a number is even or odd, because if you place the number that you want to examine here, then use modulus 2, if it divides evenly by 2, this result is actually going to be 0. So let's try it out. So 4 divided by 2 gives us a remainder of 0. And when we get to if statements, we could say, if the result is equal to 0, then this number is even. However, if this number, modulus 2, is equal to 1, then it's going to be an odd number. But I'll show you a program like that maybe in the future for a different example. But that's one practical application of how using a modulus would be useful, because you can determine if a number is even or odd. If you put your number here, then use modulus 2. So let's turn that into a comment and then move on to something else. So we'll say result equals 1, because that's the remainder. My next topic for this video, we will be discussing the use of the increment and the decrement operators. So with programming, we do a lot of counting. In fact, we do so much counting that we have our own operator that's specifically designed for counting up or down by a certain number. So let's say that we have an integer variable named total, and let's just set this equal to perhaps 1. All right, so let's say that we want to add 1 to whatever this total is. Well, we would normally have to write a statement such as total equals total plus 1. And then we can display whatever the new total is. So if we were to run this, 1, which is the total, plus 1 equals, of course, it's going to be 2. All right. So since we do so much counting with programming, we have a shorthand way of writing statements such as this if we need to increment something by 1. So instead of saying total equals total plus 1, what you just do is say total plus plus. And this will do the exact same thing. We will add 1 to whatever the total currently is or whatever variable you're working with. So this works just the same. Now, the opposite of this is the decrement operator. So we could say total minus minus, and this is the same as saying total equals total minus 1. So we could say total minus minus, and this will decrement something by 1 each time we use this. So the result here would end up being 0. Now you can increment or decrement by a given value. So with total plus plus, this increments by 1. If you want to increment by, let's say, 2, you can do something else. You could say total plus equals 2, and this will count up by 2. So the result here would be 3. And if you were to say total minus equals 2, this will subtract or count down by 2. And the result here would be -1. So let's add that to our notes. The increment operator, we can take a value or variable and just say plus plus right after the end. And then let's do the same thing for the decrement operator. So we'll say x minus minus. So use the increment operator if you want to add 1 to something, to some number or variable, and then use the decrement operator if you want to subtract 1 from a value or variable. Alright, well, next on my agenda, I have to teach you guys about typecasting because I said I would mention that. Now, what I'm going to do is copy this statement here where I say C out 5 divided by 2.0, but let's change that to 2. Alright, so normally this results in the answer being 2 because with integer division, we can't handle that decimal portion, so that gets cut off or truncated. So we have a few options to work with if we want our answer to retain that decimal portion in the answer when we're using any sort of integer division. The first is that we would need either our dividend or our divisor to have a decimal portion. They can be of the float data type or the double data type. So if we said 5 divided by 2.0, we would end up keeping that decimal portion with our answer here. Otherwise, the dividend can also be a float or a double data type, and this would work just the same. You can do it either way. Another option is this concept called casting. So you can convert a number that's of one data type to another, and what you do before that number is that within parentheses, you just write the data type that you want to convert this number or variable into. So with this whole integer of 5, we can convert this to, let's say, a double. And if we were to run this, the result is going to be 2.5, and we end up keeping that decimal portion. Now check this out. What if we put our dividend and our divisor within its own set of parentheses around this part of the equation, and then we cast this afterwards? Well, what's going to happen is that it's actually going to take 5 divided by 2 first, and then it's going to truncate the decimal and then cast it to a double, and we still lose that decimal part of this answer. Likewise, you can take a result that's normally a double and you can cast it into an integer data type intentionally so you can purposefully cut off the decimal portion. So an example of this is that we'll say C out perhaps 5.051 divided by 2.021. I'm just making up numbers here. Let's comment this out. So normally this dividend divided by this divisor equals 2.49926. All right, let's say that we want to cut off the decimal portion or truncate it. Well, what we'll do is that we'll put this within parentheses, and we're going to take the result and cast this of the integer data type. So our result is that it's going to be just 2 then. Before we move on, I'm just going to add a note that says cast to a double, cast to an int. Alright, so we finally made it to the final topic of this video, and we need to cover operator precedence. So do you guys remember in grade school where if we have a multi-part equation such as this with multiple different arithmetic operators, each of these operators has a certain precedence one over another, and what we learned in grade school was this acronym. It was PEMDAS, and one way of remembering this, which was kind of silly, is that we would say, "Please excuse my dear Aunt Sally," or something very similar to that, that used the same letters for this acronym. And what this meant is that we would solve anything within parentheses first, followed by exponents, multiplication, division, addition, and then lastly subtraction. So if we were to solve this using this order of operations, PEMDAS, we would solve, let's see, 2 times 3 first because any multiplication takes precedence over addition. So 2 times 3 is 6 plus 1. The result is going to be 7 then. So we have a different set of rules for programming, and it's actually a little bit more simple, I would say, than PEMDAS. So with programming, we solve anything within parentheses first for step 1. Step 2, we do any multiplication or any division. It doesn't matter which one comes first. We always start from the left and work to the right. And then step 3, we do any addition or subtraction at the very end. All right, so here's an example. So if you want, why don't you pause the video and see if you can guess what the total is going to be, and I'll just walk you through these steps using our order of operations for programming. So step 1, we have to solve anything within parentheses first, and we start from the left and work our way to the right. So the only place that I see parentheses is at the very end. So we're going to solve everything within here first. So we're going to say 6 plus 7 first, which is 13. All right, so we can get rid of these parentheses then because they're no longer relevant. Step 2, we need to do any multiplication and division first. So we start from the left and work our way to the right. I see 3 times 4, so we need to solve that first. All right, so then we have 12 divided by 5.0, and I changed this from 5 to 5.0 because of integer division. So this is going to be 12 divided by 5 is 2.4, so let's change that. All right, so there is no more multiplication or division, so we do any addition or subtraction. So 1 plus 2 is 3. 3 minus 2.4 is 0.6, so 0.6 plus 13 is 13.6. All right, so let's go back to see if that actually was the answer. All right, so let's run this. We probably need to display what the total is going to be. And the answer is 13.6. Well, good job making it to the end. I knew this was a somewhat more dull topic, but it was necessary for us to nail down some of these basics. And if you want a copy of what we did here today, I'm going to post it as a comment down below and pin it to the top. But yeah, that is everything you need to know to get started working with just basic arithmetic in C++. Hey, what's going on everybody? It's your bro here. And in this video, I'm going to teach you guys how we can use if statements in C++. Let's get into it. If statements are pretty sweet because it's like a basic form of decision making. We can specify some condition, and then if our condition that we specify is true, we can have our program do something. If that condition is not true, we can skip that or have our program do something else. So in C++, this is what you do to create an if statement. You just type in if, then you need a set of parentheses, and then a set of curly brackets. So anything within the parentheses will be our condition. It's like the rule. We're going to do whatever is within the subset of code between these two curly brackets if this condition that we specify is true. So there's many different things we can use as a condition, but I think we'll just start with something simple. Let's say that we want to check to see if somebody's age is equal to 18. First, let's create a variable. We could say int age equals 18. And then within the parentheses of the if statement, we can check to see if age is equal to 18. Honestly, we can really do anything with if statements. We can check just about anything. But let's check to see if age is equal to 18. Now, if you're checking to see if one value is equal to another, you don't just use a single equal sign. That is the assignment operator. So if you were to say age equals 18, well, C++ thinks you're attempting to assign the value of 18 to the variable age. So if you want to compare if two values are equal, you need to use two equal signs. And this is also known as the equals to comparison operator. So basically, if our age is equal to 18, we're going to do whatever is within this subset of code. Let's place a cout statement within these two curly brackets so we can just verify that the if statement actually worked. So we'll say cout, then use the insertion operator. Then let's display a message. Congrats, you are 18 years old. I'll just say YO for years old. Yo. All right, so let's try this out. And our result is, congrats, you are 18 years old. So what if we changed age to a different number, like 17? Well, let's see what happens when we try this. So it doesn't appear to do anything, and this is the reason why. Within our if statement, within the condition of the if statement, we're checking to see if age is equal to 18. Since our age does not equal 18, it's 17, this is going to evaluate as false, and it's going to skip over anything within your subset of code. There's other comparison operators that you should also be aware of too. So this is the equals to comparison operator. It compares to see if two values are equal. If you use an exclamation point, then an equal sign. This is the not equals comparison operator. This will check to see if two values are not equal. If both of these values are not equal, then this entire condition will be true then. So if we check to see if age does not equal 18, it will execute whatever is within our if statement. So a more appropriate cout message would be something such as, you are not 18 years old. So let's try this out and see if a message displays this time. Yeah, and it says, you are not 18 years old. And if we were to go back and change our variable age to 18 and then rerun this program, well, we don't get any result this time because we're checking to see if our age does not equal 18. Currently it does equal 18, so this entire condition will become or evaluate as false. So then if this is false, we will skip whatever is within this subset of code for this if statement, and we continue on like it never even happened. There's other comparison operators too. These you'll probably be a little more familiar with. We can say things such as greater than or less than or equal to, greater than or equal to. So I'm thinking what we'll do for this, we'll change our if statement to say if our age is greater than or equal to 18, we'll display a different message. Congrats, you are an adult. So we can basically change our age to anything, our age variable that is. Let's say that we are 90 years old, and we're going to check to see if our age is greater than or equal to 18. And it says, congrats, you are an adult. Well, you know, we're 90 years old, so we've been an adult for a long time. But yeah, you can check to see if like numbers are within a certain range too and stuff. And if we were to say our age is like perhaps 12, you know, then run this, well, it's going to skip over this if statement because our age is less than 18. It's not greater than or equal to 18. Let's move on to phase 2 of if statements. So there's this thing called an else statement. If our condition turns out to be false, normally we'll just skip over whatever is within the subset of code for the if statement. We can use an else statement if we want our program to do something else. So after your if statement, just type in else for else, and then it has its own block of code then. So basically, our if statement is going to check to see if somebody is greater than or equal to 18 years old. If it is, or if that's true, we will do this. If not, we will do something else. So let's display a different message. Let's make a cout statement that says, you are not an adult. Okay, let's test this theory. So our age is currently 12, so it says you are not an adult. And remember before when we didn't have this else statement, it just skipped over the if statement completely. But if you have an else statement, it's going to instead do whatever is within the code block of the else statement. So it's like you're at a fork in the road and your program is going to decide which path it's going to take. So I'll give you a visual example of this. So here's a visual if this helps you understand it. I actually copied this from a few other lessons on the same topic that I made in other programming languages, so don't tell anybody. But basically it works just the same. So we have our variable age, and when we reach our if statement, if our age is greater than or equal to 18, we're going to go down this path and do something else with our program. If our if statement is false, we are going to use this else statement, and our program is going to take this path and display a different message. So this is like a visual representation, if that helps you. So with that being said, I'd like to introduce a variation of the same program, or something similar to it. Now with this if statement, this condition will evaluate or return an answer of being true or false. So what if you had a Boolean variable? We could create a Boolean variable such as adult. Boolean adult equals, and we can assign this a value of true or perhaps false. And then instead of having a condition such as age is greater than or equal to 18, you could just put the Boolean variable name within here, and it's kind of like the same thing. It's going to check to see if this evaluates as true or false. If adult evaluates to be true, then we will display congrats, you are an adult. If adult evaluates as false, then we will do whatever is within this else statement. And since our Boolean variable is set to false, it displays you are not an adult. But then if we were to set this to true, then it's going to perform whatever is within the if statement then, where it says, congrats, you are an adult. So that's an alternative way to write something within an if statement, because basically it's going to return a result of being true or false. And if you were just to stick a Boolean variable in here, you can check to see if this variable contains the value of true or false. Let's move on to phase 3 on this topic of if statements, and we're going to cover the else if statement. So I think this is best if we were to create an entirely new program. So what I think we'll do is that we will prompt the user to enter in a temperature, and if the temperature falls within a certain range, we will display a certain message depending on what the user typed in for a temperature. So to begin, let's create a variable, perhaps an int, called temperature. And we can just declare this. We don't need to necessarily assign a value right away. And let's create a prompt to ask for a temperature. And we will say, please enter the temperature. Perhaps we'll put this in Celsius. Then we need to place a cin statement after this. We will say temperature. All right, so this will prompt for a temperature, and depending on what the value of temperature is, we will display a particular message. So let's write an if statement. If, I'm just going to copy temperature because it's not that fun to type this out. If temperature is greater than perhaps 30 degrees Celsius, we will display a message. So we'll say cout, it is hot outside. Maybe I'll add an emoji here. It's not required, but I think it's silly. It's a dude sweating. All right, so if our temperature is greater than 30, we will display a message. It is hot outside. So what if we want to check something else too before actually using an else statement? Well, we can use an else if statement. It's kind of like if our if statement turns out to be false, we can check one more thing or a few more things before we result to the else statement. So let me give you an example. Let's check to see if our temperature is less than 0. So I think that's the freezing point in Celsius. Let's display a message that says, cout, it is cold outside. Brr. And then let's add an else statement. Actually, you know what? I think I'm going to change this to greater than or equal to 30 and less than or equal to 0. All right, so let's add an else statement. So basically, if our temperature is not greater than 30, greater than or equal to 30, and our temperature is not less than or equal to 0, it's going to fall within a certain range of 1 to 29 degrees Celsius. So anything that falls within that range, we could say it is perhaps warm outside. It is warm outside. Okay, let's test out this program. Okay, please enter the temperature. It is 50 degrees Celsius outside. It is hot outside. Let's try a different answer. Please enter the temperature. Perhaps negative 20 degrees Celsius. It is cold outside. Now, if our temperature falls within a certain range, that's basically how we set this up. It's going to just rely on the else statement because it's checking one if statement after another. First, it checks to see if our temperature is greater than or equal to 30. And if it's false, we're going to use the else if statement, and it's going to check to see if our temperature is less than or equal to 0. If that's also false, then we resort to the else statement, and that's kind of like a last resort. So if it's not hot outside and it's not cold outside, then it must be warm outside. So let's try this one last time just to verify if that's true. So please enter the temperature, perhaps 25 degrees Celsius. It is warm outside. Well, that's the fundamentals of if statements. It's a basic form of decision making. We can check to see if some condition that we specify is true, then we can have our program do something. If it's false, we can have our program do nothing or something else entirely. I'll include copies of the programs that we made in this video, and I'll post it as a comment down below and pin it to the top. But yeah, that is everything you need to know to get started using if statements in C++. Hey, what's going on everybody? It's your bro here, and in this video I'm going to show you how switches work in C++. Let's get into it. A switch is basically a bunch of consecutive if statements. However, using a switch is much more efficient. You could say that it's harder, better, faster, stronger. So here's an example of when we might want to use a switch in place of a bunch of if statements. Let's write a program where we can enter a number between 1 and 12, and it will give us a corresponding month depending on the number that we type in. So before we get this started, let's just include one thing. We're going to type include, then a set of angle brackets, and then we're going to type in string. All right, let's create a integer named month. And we will not assign this a value right away. We'll just declare it. And let's create a prompt to ask for a month. Enter the month. Then we'll put the numbers 1 through 12 here. I think I'm going to get rid of that colon. All right. And then we are going to use cin month. I finished typing everything. So here's what you don't want to do. Writing an if statement and then writing an if statement or an else if statement right after, and it's going to check if month is equal to 1, 2, 3, so on and so forth all the way till 12. So if a veteran programmer sees you do something like this where you write a bunch of consecutive if statements, they're probably going to call you a noob. And there's a better option, and that's by using this thing called a switch. This is how you write one. We're going to type switch. Then we need an expression, or we can stick a variable within here. So we want to check the month. And then we need a set of curly brackets. In place of if statements, we use cases, and we're going to check if our value is equal to some case. And the first thing we'll want to check if our case is equal to 1. So we're going to type in case 1 colon, and then on the next line, we're going to type cout, it is January. And then this step is important too. We're going to type break. So if this case matches what we want to evaluate or check, we're going to do this and then break out of the switch, and we don't need to check anything else. So we're going to do the same thing for case 2. So case 2, then we want our program to do this. Display, it is February. And then break. All right, but you get the idea. I'm going to repeat this process for cases 3 through 12, so I'll just fast forward this video. All right, it's done. So we have cases 1 through 12, one corresponding to each month of the year. So let's test out this program. Enter the month. Well, currently it is April, so I'm going to type 4 and hit enter. So 4, enter. and it says it is April. Let's try a different month. I'm going to type in 12, hit enter, and it says it is December, so we know the switch is working. What happens if we type in a number that doesn't match any of these cases? Well, let's see what happens. So it says enter the month. I'm going to type in the word pizza. So nothing appears to happen. So what we can do is that we can place a default case. What do we want our switch to do by default in case there are no matching cases? So we're going to write default at the end. And what do we want our program to do? So first, make sure you write default and then add a colon at the end. And let's simply display a message that says, you did not enter a number between 1 and 12. Enter the month. It is pizza month. You did not enter a number between 1 and 12. So it's similar to an else statement where it's like a last resort. If there are no matching cases, we'll have our program do this by default. So how this works is that the switch expression is evaluated at once and selects one of these many code blocks depending if there's a matching case or not. If there's no matching case, we can execute whatever is within the default code block. Now with these break keywords, these are important to have after each case, and if you were to take these out, we would continue on to the next case as if the next case was also true. So let's try this program again and take out a few of these breaks and see what happens. Enter the month. It is April, so I'm going to type in the number 4 and hit enter. And our result is, it is April, it is May, it is June, it is July, it is August. So if you're missing a break within a case, it's going to continue on to the next case as if that next case was also true, and it's not going to stop until it reaches a break. And these cases don't necessarily have to be numbers. Let's try another example using char values, characters. I have an idea. Let's write a program that will ask for a letter grade, like in school, the letters A through F, and we will give a response based on what letter grade that we answer with. So to begin, let's create a variable that will store a single character, a char value, and we will say answer, and we don't need to assign this a value right away. Next, we will say cout. This will function as a prompt. What letter grade did you get? And perhaps I'll just put A through F in here. And then we will say cin answer. Let's create a switch. So switch. Then this part's the expression. We'll just put our answer within here. And we will check this answer against many different cases. In our first case, instead of 1, we're going to type in A within single quotes. So if our answer matches this case where it's A, the character A, what do we want our program to do? Perhaps a simple message such as, you did perfect. And then we want to break. All right, let's repeat the same process for the other letter grades. So case B. What do we want our program to do if this case matches? You did good. And then break. And it's just a matter of repeating the same process for each of these letter grades. So case C, cout, you did okay, and break. Case D, cout, you did not do so good. It's still passing though. And case F, cout, you failed. And break. We can add a default code block, so let's do that. We're going to type in default, and we will display a message. Enter a letter grade, A through F. Oh, I guess we're missing E, but who cares? Let's run this program and see if it actually works. What letter grade did you get? I got an A. So I typed an A, hit enter. You did perfect. All right, we got an A, everybody. What letter grade did you get? I got an F. You failed. Have a nice day. All right, then let's type in something that's not a letter grade, like the word pizza. And we get that default message of enter a letter grade A through F. So we know the switch is working. But yeah, you're not limited to just using numbers for your cases. You can also use characters and other things too. So just to summarize what we did here today, a switch is more efficient than using a bunch of consecutive if statements. We can take a value or expression and compare it to see if it's equal against many cases at once. If there is a matching case, we can activate the corresponding code block and have our program do something that we specify, and then we can use the break keyword to break out of the switch and continue on with the rest of the program. And we can also add a default code block if there are no matching cases. We can have our program do something by default. But yeah, that's the basics. If you want a copy of the examples that we worked on today, I'll post it in the comments down below and pin it to the top. And if you're looking for practice or a project to work on, why don't you create your own switch and then post it in the comments down below. But yeah, that's the basics of how switches work in C++. How's it going, everybody? It's your bro here. I hope you're doing well. And in this video, I'm going to teach you some useful functions related to strings in C++. Let's get into it. This video is going to be more of a showcase of the different string functions that are available to us, so we're going to be covering a lot of them. If there's any that you want to see in particular, look in the description for any timestamps and you can hop around if you want. We're going to kick this off with the string.length function. This returns the length of a string that you specify, so let me show you how this works then. We're going to create a string named perhaps first name. And we're not going to assign this quite yet because we're going to accept some user input. Now we're going to see out a prompt. Enter your first name. And then we're going to use get line. cin, comma, first underscore name. We can use the length function to determine how long our name is, and we can actually store this as an integer variable. Or we don't have to, but I'll show you a good use. So length equals whatever string that we want to determine what the length is. So first name dot length and then a set of parentheses. So you'll notice with a lot of these functions that they will end with a set of parentheses. So pay attention to that. All right. So we have our length. Now what? Well, I'll show you a good use then. We can check to see if somebody's name is too long. Like if they create a username, we can determine if it's too long or not. We can have them choose something else. So perhaps if, leave this within parentheses, length is greater than or equal to 12, then what we will do is display a message. Your name can't be over 12 characters long. Okay. Else, see out, welcome, then we'll display your first name. All right, let's try this. Enter your first name. I'll just type in bro. Welcome, bro. All right, so that worked just fine, but I just want to change something real quick because it's bothering me. I just want to give a space when you enter your name in. Okay, let's assume that we have a very long username. So let's try this again then. Bro, my username for other things is usually Prometheus, so let's use that. Prometheus 42069WTFBBQ. That looks like a good username to me. Your name can't be over 12 characters long. So that's a good use of the length function. Oh, and another thing with the length function, and actually many functions, is that you don't necessarily need to assign this to a variable. We could just take this, delete it, and then place this within our if statement. So this would actually work just the same within less steps, even though it's a little more complex, I would say, but it takes up less lines of code. So let's try it. So bro 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's move on to the empty function. So you can use a strings empty function to determine if any characters were placed within that string. And a good use of this is that if you prompt for a name and somebody just skips it by hitting enter, we can actually determine if that string is actually empty then. So let's try this then. We'll put this within our if statement. First underscore name, and we're going to use the dot empty function, and then we need a set of parentheses. So if the first name is empty, it's going to execute our if statement. If not, it's going to use the else statement. So we can create a prompt such as you didn't enter a name. Okay, let's see if this actually works then. Enter your first name. I'm just going to hit enter. You didn't enter a name. Then let's try it again, but put a name in. So bro, welcome bro. The clear function will clear the contents of a string, so it's useful if you need to reset something. So in this little program I wrote, we just have a basic welcome message that displays welcome, and then your first name or username, whatever you enter, it'll say that your name has been cleared. We'll actually clear it by typing in the string that we want to clear. So first underscore name dot clear, parentheses, then a semicolon, and then we will display that welcome message one more time then. So let's see if this works. Enter your first name, bro, welcome bro, your name has been cleared, and then it says welcome, and then nothing after that because our first name string is now cleared or emptied. So that's useful if you need to like clear out a form or some user input, just use the clear function. The append function will allow you to add one string onto another. So a good use for this is that imagine that you are prompted for a username, and then we can actually append an email extension to the end of that to create an email address. So let's create a string called email, and this will hold the newly appended string. So we will append our username, so username. So this is the string that's getting appended to, dot, then append, parentheses, semicolon. Make sure it's outside the parentheses though. All right, so we can put a string in here to append to this username, our first string. So let's add a gmail.com email address, and then we're just going to display this. Okay, enter your username. I'll type in bro. Your email is now bro@gmail.com. I'm pretty sure that's taken. The @ function will return a character at a given index that you specify. So we're going to write a program that will extract the initials from a first name, a middle name, and a last name. So let's create a char variable. So this returns a character value. So we'll call this char value perhaps letter1 equals, then your first underscore name, then @. Then next we need to place a position of which letter we want to check or extract. If you want the very first character or letter, just put it in 0 because it's a computer science thing. Like all arrays basically, or strings start at index 0. All right, so then let's do the same thing for the middle name and the last name. So let's call this letter2, middle name, letter3, last name, and then let's display this. See out. Your initials are, then we will display letter1, letter2, and letter3. Okay. Enter your first name, bro. Enter your middle name. I'm going to make up something, max, like maximum. And last name, Washington. Your initials are BMW. And if we change the index for this at function, we would actually extract a different letter. So let's see what our initials are now. So bro, Max, Washington. My initials are Ra because it's technically the second character within each of these string variables now. So that's how you can check to see which character is at a certain position in a string, and then this function will return that as a character that you can use for other things. The substring function will return a portion of a string, and it's called a substring. So an example of this, let's create a program that you'll enter in a first name, and then we'll take a small sample of that and create a nickname for you. So let's create a string named nickname. Let's say that we want to take the first 3 letters of your name and create a substring out of it called nickname. So we'll type in the string that we want to use. So first underscore name dot sub str for substring, then a set of parentheses, semicolon. Okay, so there's 2 things that we're going to want to fill out. The first is the starting position. So let's say that we want to start the substring at the first character of your first name. We're going to put 0 here. Let's say that we want to retrieve the first 3 letters perhaps. So we'll put 3 here. If you want 4 letters, then just put 4. So let's stick with 3 then. And then we're just going to display this nickname. Let's try this. Enter your first name. Let's type in my full username of Prometheus. And it says, your nickname is Bro. Hello, bro. Okay, so we can actually change where we want to take our sample for our substring. Let's say that we want to move this to position 3, and we want to extend this for 5 characters now. So we're going to take another sample of our first name, our string, and we'll get a different substring then. So Prometheus, I don't know what this is going to be. Your nickname is meth, like crystal meth, I guess. The insert function is very similar to the append function, but we can take a string and then place it anywhere within another string. We just have to give the position in which we want to insert this other string. So this actually doesn't return anything. And this insert function doesn't actually return anything. It currently edits the string that you're currently working on. So let's take our username, dot, then insert, set of parentheses. So there's 2 fields to fill out. The first is the position in which you want to insert something. So let's say that we want to insert a string or a character at the very first position. So we're going to put 0, comma, then what we want to insert. Let's say that we want to insert the @ symbol, like we're replying to somebody. So we'll just put this index at 0 and then we'll insert this @ sign, this string. So let's try this. Enter your username, bro code, and it inserted a @ symbol before our actual username at index 0. So let's place this somewhere else. How about at position 3? So let's try this again. Bro code. And it placed this @ symbol at position 3 within our string. So it's kind of like we pushed these 2 parts of our string to the side and it inserted this right in the middle. This find function is very useful because you can search for something within another string and it will return the first instance of that substring that you specify. So let's create a program where we have somebody enter in their first name or a username, and then we can search for a certain character or a string and return where it found that certain character. So this is kind of like you're on a web page and then you can use that find feature to find some sort of text on the web page, and it's going to return where it found that first instance of that certain text that you specified. So it's the same concept really. So this will return a integer value, and we'll call this position equals, we want to search our first string. that was called first_name dot find. And what do we want to find? We'll find a substring, our variable substring. All right, so let's run this. So we can actually decide on what we want to search for with this. Enter your first name. I'm just going to type in bro code. Search for which character. I want to find any C's in here, capital C's. It found this character at position 3, so 0, 1, 2, 3. That's kind of cool, right? So this is the erase function. We can erase a portion of a string. One use for this. So do you know with phone numbers how they usually begin with an area code? Well, let's prompt for the user to enter in a phone number, and then we'll erase the area code, leaving whatever the rest is. So we'll use the string phone number dot erase. Then we need to place a starting position, a starting index. Let's say we want to erase the first 4 characters. So it's going to start at position 0, and we're going to erase 4 characters from the string. Okay, and then we'll display it at the end. Okay, enter your phone number. I'm just going to make up something with an area code. So perhaps 101 1, 2, 3, 4, 5, 6, 7. Okay, our new phone number is 1, 2, 3, 4, 5, 6, 7, and it erased the first 4 characters of our phone number, so it erased that area code basically. So we're about out of time. There's still many more functions that we haven't covered, but if we did, we'd probably be here all day. So instead, I'll link a resource to basically a web page that contains more functions that you may or may not be interested in. But there's still a lot more that we haven't covered. These are just a few. And then if you have some free time, feel free to browse the resource I'll give you if you want to learn a few more. I'll post the source code that we worked on in the comments down below and pin it to the top. But yeah, that's the basics of using string functions in C++. Hey, what's going on everybody? It's Bro here again, and in this video we're going to be covering some useful math functions in C++. Let's get into it. I promise that this video won't be as boring as the last one on string functions. It's probably going to be even worse. No, it won't be that bad, but here's a few math functions that you might find useful for your programs. First thing that we're going to want to do is include something at the top of our program, so outside of your main method we're going to type this. Hashtag include, then within angle brackets, algorithm, but make sure you spell it right. Just like that. Not all functions that we'll be covering will need this, but a few will, and I might forget to mention this later on in this video, and it would be a pain in the butt to have to re-edit this and show you the part of the video where I include this, so let's just get this out of the way and include this now. So this video is going to be more of a showcase of different math functions that we can use in C++. And if you want to skip around in this video, that's completely fine. I'll include some timestamps in the description if there's any math functions that you'd be interested in. The first math function we'll cover is the max function. We can find the higher of 2 numbers and return the higher number. So let's write a program that will ask the user to enter in 2 numbers, and the program's going to return the higher number. So let's create 2 double variables. So these can store a decimal portion. It doesn't need to be a whole integer when we write this program. So double x and double y, we're not going to assign these a value quite yet. And then let's create a prompt. Perhaps this program will enter the max of 2 numbers. All right, and then we are going to create a prompt to enter in number 1. Enter in number 1, and then cin x for our first number, and we'll do the same thing for y, but we're going to change a few things. Enter in number 2, and we're going to change x to y, and we can place the result within another variable if we so choose, like double z. So if we want to find the max of 2 numbers, we're going to use the max function. So type in max and then a set of parentheses, and we're going to put two numbers within here, and we can just put the variables x and y. And then let us display the result. So we'll just see out z. Okay, everything looks good. Let's run this. False alarm, I have to make a few edits. So I forgot to end the line. And I'm just going to add a space after this, colon space. All right, it should look better now. All right, this program will enter the max of two numbers. Enter in number 1. How about the number 24? Enter in number 2. You know it's better than 24. 25. And the max number is 25. All right, now with the minimum function, it's going to be the same process as before, but we're just going to change a few things. We're going to change max to min within our little message here. And we're going to switch max to min. So this will find the minimum between two numbers. So let's run the same process that we did last time, 24 and 25. And the minimum is obviously 24. Big surprise there, right? The power function, man, that's a pretty cool name, power function. It returns a number to the power of another number. So in our message, what we'll say is this program will return x to the power of y. All right, so enter in number 1, that's right, enter in number 2. Now we're going to use the pow function. That also kind of reminds me of like those old comic books like Batman, where they had like sound effects for all their kicks and attacks. But I'm getting off track again. Okay, let's run this. Pow, pow, bam. All right, this program will return x to the power of y. Enter in number 1, perhaps 3. Enter in number 2. Let's say 4. So the result is going to be 81, and that sounds right. 3 to the power of 4 is 81. Let's talk about square roots. So the square root function will return the square root of a variable or number that you place within the function. For this demonstration, we will no longer need the y variable, and we can get rid of this prompt. All right, so this program will return square root of a number. All right, so enter in the number. Okay, so then what we're going to do here is just type in SQRT for square root and then a set of parentheses. And we're going to place the number or variable that we want to find the square root of within the parentheses here. And then this variable z will store it and we can display this. All right, let's run this. All right, enter in the number to find the square root of. Perhaps 64, that's a nice number. And the square root of 64 is 8. The absolute value function will return the absolute value of a number. That's basically its magnitude. Think of it like how far away the number is from 0 is going to return a positive number. So let's change our message to this program will return the absolute value of a number. Enter in the number, that's good. All right, what we're going to do here is change this SQRT to ABS, like abs, six-pack abs, but it's short for absolute value. All right, let's run this. This program will return the absolute value of a number, enter in the number. So let's say negative 42. So this will return the magnitude of the number, basically how far it is away from 0, and it's always a positive number. So the answer is 42. The round function will round a number to the nearest whole integer. So what will change here is this program will round a number to the nearest whole integer. All right, enter in the number. And what we're going to do here is type in round, parentheses, and then place our number within here, so x. All right. This program will round a number to the nearest whole integer, enter in the number. let's type in the number 3.14, the first few digits of pi. And the result is 3. So the nearest whole integer to 3.14 in regards to the decimal portion is 3. Now, what if we were to type in a different number like 3.5? It's actually going to round it up as long as the decimal portion is at least 0.5. So there's a few other round methods too you might be interested in. The ceiling function will always round a number up to the nearest whole integer. So this program will round a number up. I don't feel like typing that much. And what we're going to type in here for the ceiling function is, it's shorthand, CEIL for ceiling, like you're touching the roof, the ceiling. So let's type in 3.14 again and see what the result is. So it's always going to round it up if there's at least a decimal portion. If this was like 3.0, this would stay the same as 3, but it's always going to round it up. And the opposite of this function is the floor function. If there's a ceiling, there's a floor then. So this program will round a number down to the nearest whole integer, and we're going to replace this CEIL with floor, like the floor of your house. And we'll run this. Okay, so let's type in a number with a very high decimal portion, like 3.9999999. And this rounded down to the nearest whole integer, which was 3. So those are just a few of the math functions available to you. We only went over a few of the basics. There's still way more out there. I'll post a resource that you can go to if you're interested in more math functions, but these were just the basics. I'll also post the code that we worked on in the comments down below and pin it to the top if you would like a copy. But yeah, those are some basic math functions in C++. Hey, it's your bro. Hope you're doing well. And in this video, we're going to be discussing the AND as well as the OR logical operators in C++. Let's get into it. Logical operators allow a program to make a decision based on multiple conditions. So, for example, we can create an if statement with more than one condition. And for this video, we'll be talking about the AND as well as the OR logical operators. Let's begin with the AND logical operator. We can check to see if one condition and some other condition is true. If both conditions are true, as in one and the other one is true, then the entire expression is true. If just one of them is false, then the entire expression is false. So let's create a program where this might be useful then. Let's create a program that will ask for somebody's temperature, and if it falls within a certain range, we will display a message. So let's create a double value so we can store a decimal portion depending on what temperature they type in. And let's just create a variable named temp, short for temperature. And we'll create a prompt to ask for the user's temperature. Enter your temperature, and perhaps we'll put this in Celsius, and then we'll want to assign this variable temp. Alright, so then let's create an if statement, and this will display a message if it falls within a certain range. Alright, so let's begin with if our temperature is greater than or equal to 35 degrees Celsius, then we'll display a message such as your temperature is normal. Alright, but what if somebody's temperature is like 200 degrees Celsius? That's obviously not normal. So we would want this to fall within a certain range. So we can use the AND logical operator to check one more condition. So we can say, if temperature is greater than or equal to 35, and temp is perhaps less than or equal to 37.5. Then we will display this message. Else, we can do something else, such as display a message like, go to the hospital. But I spelled it wrong. Okay, let's run this. Enter your temperature. I have a temperature of 150 degrees Celsius, and it says go to the hospital, because that is obviously not normal. So if we want this if statement to execute, it needs to fall within this certain range. This condition has to be true, as well as this condition has to be true. Since we said our temperature is 150 degrees Celsius, this portion is true, it evaluates as true, but this portion evaluated as false because 150 is not less than or equal to 37.5. So in order for us to execute this if statement, it has to have both portions of this expression become true. So let's try it again, but we'll have it fall within this range then. So perhaps my temperature is 36 degrees Celsius, your temperature is normal. And with these and logical operators, you can add more than one. For example, we can put this portion within its own set of parentheses, and we can check something else, such as temp does not equal 0. I guess it wouldn't really make sense for this example since we're already checking to see if temperature is less than 37.5. But this is one way that you can check a total of 3 things, or maybe even 4 things if you add another and logical operator. But that's basically how the and logical operator works. You can check to see if one condition and some other condition is true. If just one of them is false, then the entire if statement or entire expression is false then. Let's clear what we have and move on to the or logical operator. So the or logical operator is somewhat similar to the and logical operator, but it will check at least 2 conditions. If one of the conditions is true and the other is false, then the entire expression is true. The only way that the entire expression will evaluate as false is if both conditions are false then. So let's create another similar example. It's going to be a program that will ask if you have a cough. So let's let's declare a string variable named cough, all right? And we will ask for a prompt, do you have a cough? Then we'll write within parentheses like the answer that we expect, like yes or no, all right? And then we will assign the answer to our variable cough, which can hold a string. But I'm forgetting a semicolon. Okay, then let's write an if statement. If, and I think the best way to handle this that uses an or logical operator is that we can say if our string cough, and we're going to use the at method, and we're going to check to see if the character at position 0, index 0 of our string cough is equal to the character perhaps y, all right? So that means somebody's responding with yes, or maybe a yeah. And then we will say, see out, you are sick. And then let's write an else statement. Else, you are probably fine. All right, so here's a scenario. What if somebody types in a capital Y for when they type in the word yes? Let's try it. All right, so maybe for this first run, let's just type in yes just to be sure that this is working. All right, do you have a cough? Yes, you are sick. Now let's type that in again with a capital Y. Yes, all caps. You are probably fine, but that's not what we expected. So why don't we check to see if some other condition is true within our if statement, and we can actually use the or logical operator, which is 2 of these vertical bars. And we will also check to see if cough at index 0 equals the capital Y, a capital Y. So as long as one of these conditions is true, then this entire expression is going to evaluate as true. Even if one of these conditions was false, as long as one of them is true, then this entire expression is going to be true then, and we will execute whatever is within the code block of this if statement. So let's try this one more time. Do you have a cough? Then we'll just type in all caps, yes. You are sick, which is what we wanted then. So then, just like the and logical operator, we can check to see if another condition is also true or not. So you can just add another set of these vertical bars if there's one more thing you want to check. So you're not limited to just 2. Surprise, we're going to be talking about one more topic, and we've discussed it previously in another lesson, and that is the not logical operator. And basically what this operator does is that it will inverse an operand, it will reverse the true or false outcome of an expression. And I know we've talked about this previously, but it would be a good point to touch base with this just because this is technically a logical operator. And if there's anybody new to this channel and they didn't see the previous videos, they'll actually be informed about this now. So let's just touch base with this real quick. So let's create a program that will ask for a user's name, and depending on what they type in, it will either display a welcome message or it will display a message such as "you did not enter your name" if somebody just skips the prompt. So let's create a string variable named name. All right, and then we'll create a prompt to ask the user for a name. So cout, enter your name, and then we will use the getLine function, and within here we'll type in cin name. So this is in case somebody types in a first name and a last name. It will actually assign the entire line of input. All right, so we'll use an if statement, and then within the if statement we'll check to see if our string name is empty, and we'll use the empty method that we learned about. So we'll just type in name.empty. So if the name is empty, they must have skipped it, and we will display a message such as, perhaps we'll yell at the user, "You did not enter your name." Frowny face. All right, so then if the name is not empty, then they must have typed in something. So we'll display a message like a welcome message that says, "Welcome," whatever the user's name is. All right, so let's try this. And then after this run, we'll try and use the not logical operator in action. So enter your name, I'm just going to hit enter to skip. You did not enter your name. All right, with this program, there's another way to write this, and we can use the not logical operator. So this will basically inverse the operand. If it's false, it's going to flip it to true. If it's true, it's going to flip it to false. So if we place this not logical operator before this name.empty method, if the name is empty and this pops up as true, this is going to flip it to false, and the inverse of that too. So if basically our name is not empty, we can actually display this welcome message. So if the name is not empty, we will display our welcome message. Else the name must be empty then, so we will have our message that says, "You did not enter your name." Let's try this and see if it works just like before. So enter your name. I'm just going to hit enter. You did not enter your name. Let's try it one more time, but let me fix some syntax here. All right. Enter your name. This time I will type in my name and just type in bro, and it says welcome bro. Well, those are 3 logical operators that you would find useful: the and, the or, and the not logical operators. I'll post the code that we worked on in the comments down below and pin it to the top if you want to take a look or you'd like a copy for yourself. But yeah, those are how logical operators work in C++. Hey, how's it going everybody? It's your bro here. Hope you're doing well. And in this video, we're going to be discussing while loops in C++. Let's get into it. So we're going to be talking about while loops. All while loops are is that we can execute some code repeatedly while some condition remains true. This is how you write a while loop. We're just going to type in while, then we need a set of parentheses, and then a set of curly brackets. Now, within the parentheses, this is our condition. As long as some condition within here is true, we will execute whatever code is between these curly brackets over and over and over again. But it's also important to add a way to exit the while loop. Otherwise, you're stuck in what's called an infinite loop. So here's an example of an infinite loop, and this is what you don't want to do, all right? So we're going to set the condition while 1 is equal to 1. We'll display something, maybe a message. So cout, help, I'm trapped in an infinite loop. And then let's add an end line after this. All right, well, let's see what happens. Let's run the program. All right, as you can see, it's just repeating this code that we have within the while loop over and over and over again, and it's not stopping because we don't have any way to exit this while loop. So it's important to add a way to exit your while loop so you can continue on with the rest of the program. As fun as this is, it's not practical. Now, I'll demonstrate a good example of us using a while loop that's actually practical this time. For example, we could prompt someone to enter their name, and we can keep on asking them if they don't enter in their name if they try and skip it. So it's a great way to force the user to enter in something, maybe some information, because we won't let them continue with the rest of the program until they do something or enter that information in. So let's create an example of that where we're prompting a user to enter their name in repeatedly until they actually do. So let's create a string variable named name, and we're not going to assign this right away. So this is the syntax for a while loop again. We're just going to type while. We're going to put our condition within a set of parentheses, and then all of the subset of code for the while loop is going to be between two curly brackets. So what we're going to check within the while loop, this will be the condition, perhaps if name is empty. So we're going to use the string empty function, and it will check to see if our name is empty. So if this condition remains true, what are we going to do? Let's create a prompt such as, please enter your name. And we'll add an end line after this. And then we will get line cin the user's name, whatever they type in. And then once we exit this while loop, we'll display a welcome message. So cout welcome, then the user's name. All right, let's try this. All right, please enter your name. I'm just going to hit enter to skip this part, and it's having us enter our name again. No, no, no. All right, so then it's just going to continue on and on until I actually enter in something. So now if I want to exit this while loop, I'll have to type in a name, and I can't continue on with the rest of the program until I do. So I'm just going to type in bro, hit enter, and we escaped the while loop, and it displays our welcome message, and it says, welcome bro. So that's a good example of us using a while loop that has some practical uses. One thing to pay attention to with while loops is that if our condition is false from the beginning, we will actually skip this while loop and completely ignore it and continue on with the rest of the program. So an example of this, let's say for our name, let's assign this a value, and I'll just type in an empty space, all right? So what would happen if we assign this a value and this condition within our while loop is false from the get-go, from the beginning? Well, this is what happens then. We just skip it completely. So in order to even enter the while loop, the condition has to be true then. If it's not true when we reach the while loop in our program, it will skip it completely if it's false from the beginning. Now, there's actually a variant of the while loop that solves this problem for us, and it's called a do while loop. We will always perform this subset of code at least once, but then only continue if the condition is true then. And I'll give you guys an example of a do while loop. So let's clear everything we have here, and maybe I'll just make a note that this is a do while loop. There's different spellings of this, but it's essentially the same thing. So a good example of this, do you remember from old video games like Oregon Trail where you had to press Q to quit the game? Well, let's create an example of something like that involving a do while loop. So while we don't press the Q button or Q key or enter in Q, we will continue to play this game that we make up. So let's create a string variable named answer, and we're not going to assign this right away. Now we're going to use the do while loop. So we're just going to type in do, then a set of curly brackets, and then after this, we're going to type in our while loop. All right. And then you have to finish that off with a semicolon because I'm forgetting that. So we're going to put our condition between these parentheses at the very end. So we will always execute this loop at least once, and then at the end, we're going to check to see if this condition is true. If it is, then we'll continue with this do while loop. So let's create a fictional game then. It's going to have really very poor graphics, all right? So you are playing the game. It's just going to display something, really. and let's end line. Let's make this fun. Pew, pew. And then I'll ask for a prompt if the user wants to exit. Perhaps I'll just type in or add a prompt that says maybe press Q to quit. And then let's add a get line here. So get line C in, and then the answer. And I'll just add one more line of text here, just to kind of keep things organized and separated. All right, so we're going to execute this do while loop at least once, and then depending on our answer, this will determine if we're going to exit the do while loop. So we'll need to write some sort of condition within the while loop. So we can check to see if our answer is Q or not. And one way to do this is that we could say answer dot at index 0, all right, does not equal Q. All right, so this will take whatever we type in, and if it begins with the letter Q, then we will exit the while loop then, as long as it doesn't equal Q. However, if they type in capital Q, we'll also have to count for that too. So we're going to use the AND logical operator. Answer at index 0 does not equal uppercase Q. All right, so let's run this. Oh, then we should probably write a prompt to let the user know that they have exited the game. So you have quit the game. Okay, we should be good. So we're going to perform this code block at least once, and then depending on our answer, that will determine if we exit this game or not. So let's try this. You are playing the game. Pew pew, press Q to quit. I don't want to quit, so I'll just type in still playing, and it says I am still playing the game. No, I don't want to quit. You know what, this game is kind of lame, so I want to quit the game, so I'm going to type in Q to quit, and it says you have quit the game. So you can see that with the do while loop, you'll always perform this code block at least once, and then at the end, we will check our condition. Then if the condition evaluates as true, we will continue to repeat this do while loop over and over again. So that's a variation of the while loop. It's a do while loop, and it's if you want to execute this code block at least once. Otherwise, with the basic while loop, you might just skip it completely if the condition is false from the beginning. So that's this topic on while loops. I'll post all the code that we worked on in the comments down below and pin it to the top. And if you're looking for additional practice or a project to work on, why don't you create your own example of a while loop and a do while loop, and also post it in the comments down below. But yeah, that is this topic on how while loops work in C++. Hey, it's your bro. Hope you're doing well. And in this video, we're going to be discussing for loops in C++. Let's get into it. For loops are fairly similar to while loops, which we covered in the last lesson, and at first it might be difficult to understand the differences between the two. So for loops are used to repeat some code only a limited amount of times, compared to while loops where it can be repeated infinitely. So the advantage of for loops is that we know how many times that a for loop is going to iterate before it even begins. For example, we could create a for loop that can count down from 10, and once we reach 0, perhaps we could display a message such as Happy New Year. But first, let me give you the basic syntax of a for loop. So this is the basic structure for a for loop. We have the word for, a set of parentheses, and then a code block for this for loop. And we'll put whatever code we want within the code block, and we'll have that repeat so many times. Now, within the parentheses of the for loop, there's going to be 3 statements, and each of these is going to have a specific function, and each statement is going to be separated with a semicolon. So let's create a for loop. Sounds good, right? Let's create a program that will begin by counting up to 10 and then display a message, and then after that we'll do the reverse and count down from 10. So we'll need to add that structure that I showed in that last slide. So we need the word for, a set of parentheses, and then a set of curly brackets for the subset of code for the for loop. Now, there were 3 statements to fill within the parentheses of the for loop. The first is some sort of index or counter, and you can declare a counter like variable in here. You can name this whatever, like index or maybe counter or maybe even x. Commonly, you'll see people declare a variable named I as like index, and then we can set this equal to a number, perhaps just 1. So this is our first statement. We're setting up a counter for this for loop to track how many times this for loop has repeated. Next, we'll need some sort of condition. When do we want this for loop to stop? Let's say that we want to count up to 10, so we'll continue this for loop as long as I is less than or equal to 10. That's our second statement. And next, we can increment or decrement our counter, and we could just say I++ for shorthand. So one key feature with for loops is that we know how many times that this for loop is going to repeat before we actually get this even started. So if I is 1 and we're going to continue this for loop as long as I is less than or equal to 10, we're going to be repeating this for loop 10 times. Compared to while loops, we don't know how many times we'll be repeating a while loop. That's as long as some condition is true. So what do we want to do during each iteration of our for loop? Let's just display whatever our counter I is. So cout I, then end line. And then after we exit the for loop, we can display a message such as you can count to 10. So this program is simply just going to count to 10 and display this message. That's basically it, but let's test it out, then we'll make a more sophisticated program involving for loops. Okay, so this went by fairly quickly because we weren't adding any pauses or anything, but you can see that it repeated the for loop 10 times, and it's just counting how many times it repeated. And then once we exited the for loop, it continued with the rest of the program, and it displayed that message, you can count to 10. This time we're going to count down from 10. So for our counter I, let's set this equal to 10. And for our condition, we'll continue this for loop as long as I is greater than or equal to 0. Now, we're not going to increment I, we're going to decrement it. So we're going to type in I, then minus minus. So after each iteration of this for loop, we're going to subtract 1 from our counter. And then we're going to display whatever our counter currently is, and then once we exit the for loop, we will display a different custom message. Happy New Year. All right, so same process as before. Let's run this. All right, so let me expand this window. We started from 10. After each iteration of the for loop, we're counting down by 1. Once we hit 0, then we exit the for loop, and it displays our custom message. And with this third statement where you can increment or decrement your counter, you can also increment it or decrement it by a certain amount. Let's say that we want to count down by 2. Well, we could say I minus equals 2. So we will then count down by 2 starting from 10. Yep, you can see that here. We're counting down by 2 each time. Likewise, you could do the opposite where you can add as well. So if you want to count up by 2, you would just say I plus equal 2, and it's not limited to just 1 or 2. You could do like 3, 4, doesn't really matter, but commonly people will increment or decrement by 1. And an alternative way of writing this is that you don't necessarily need this third statement within the parentheses. You could add this increment or decrement counter at the end of your for loop, and this would work just the same too, but commonly you'll see people put it within the parentheses. So yeah, you can see that this worked just the same, but there's an alternative way of writing these for loops too, but commonly you'll see people have all 3 statements together for their for loops. So the main difference between a while loop and a for loop is that a for loop will execute a limited amount of times, and we already know how many times the for loop is going to iterate before the loop even begins. And with while loops, we do not know how many times the while loop will iterate necessarily. It's as long as some condition remains true. It could be infinite. So here's an example of the differences between a for loop and a while loop. So imagine we're in the military and our drill sergeant is instructing us to do push-ups, and he says, drop and give me 20. This is a perfect example of a for loop because we already know how many iterations, how many push-ups we're going to be doing. We're going to do 20 push-ups and then we're going to stop. An example of a while loop would be a drill sergeant telling us that we need to do push-ups until he says we're done. So we're going to start doing push-ups until the drill sergeant says we're done then. And it could be forever. Who knows? It could be 20. It could be less. It could be more. It's while some condition remains true, basically. So that's the main difference between a for loop and a while loop. We already know how many we're going to do. With while loops, we don't really know. Let's create another program involving a for loop. This program is going to ask for a word from a user, and then it's going to use a for loop to spell out each individual character in the word that we give as user input. So this is what we're going to do. We'll create a string variable, perhaps named word, and then we will create a prompt to have the user enter the word to spell. Then we'll use cin or getLine, whatever the word is. We'll create a for loop, so for, a set of parentheses, then a set of curly brackets. Then we'll need to place the 3 statements within the parentheses of the for loop, and we'll have to add the 3 statements to this for loop. The first is the index or counter, so we're going to declare a variable named I, and set this equal to 0. And the reason that we're setting this to 0 is because with strings, the first position is always 0, and then the next position is 1, then 2, then 3, so on and so forth. Next, for our condition, what we're going to type here is I is less than our word dot, then we're going to use the length function. So this is going to return the length of whatever word we type in. So this might change every time we pick a new word to enter in. And for the last statement, we're going to increment our counter by 1 every time we iterate through this for loop. Now within the code block for the for loop, what we're going to type is cout, then we're going to type in the word, our word variable, dot, and we're going to use the at function, all right? And then do you remember in the previous lesson on string functions, if we wanted the first character of a string, we would put 0 within here. If we wanted the second character, we would put 1. What we're actually going to do for this for loop is place our counter I within here. So during the first iteration, I is going to equal 0. So we're going to display whatever the first character is. Then after we complete 1 cycle of the for loop, our counter I is going to increase by 1. So then when we reach this statement for the second time, it's going to display the second letter. After the next iteration, it's going to increment by 1 again, and then it'll display the third letter. So it's going to display all the letters of a word that we type in. And I think I'll just add a space between each letter. There's just one thing I have to fix before we run this program. I'm just going to add a colon and a space to our prompt. Okay, let's test this. Enter the word to spell. I'm going to type in the word pizza, and our program will display each letter of the word that we type in. So basically, a for loop only iterates a limited amount of times, and we know how many times it's going to iterate before the loop actually begins. So that's basically this lesson on for loops. If you would like a copy of the code that we worked on today, I'll post it in the comments down below and pin it to the top. If you would like additional practice or a project to work on, why don't you create your own program that includes a for loop and post it in the comments down below. But yeah, that is how for loops work in C++. Hey, it's your bro. Hope you're doing well. And in this video, we're going to be discussing nested loops in C++. Let's get into it. All that nested loops are is this concept of having one loop that's inside of another loop. And these come in handy when we get to this topic on 2D arrays. They're going to be heavily used, these nested loops. So the generic syntax of a nested loop, you can either have a for loop or a while loop. There's other types of loops out there. I'm not going to bother with filling this in. So it's basically you have one loop that's inside of another loop, So it's as if we're stuck within two loops now instead of just one. There's an outer loop and there's an inner loop. And it's still possible to have more levels to this than just two, but let's keep it simple for now. So when we enter this inner for loop, we're going to be stuck cycling through this inner for loop a certain amount of times, and once we're able to exit, we can finish an iteration of the outer loop, but we may have to continue cycling through this outer for loop depending on what kind of condition we have, and once we begin a new iteration, we get stuck back within this inner for loop again and have to keep on cycling through this. So I think it would be best if I give you a demonstration of this. So we're going to create a program where we can print out a rectangle of a certain symbol that the user chooses, and we're going to give a symbol, a width, and a height to this rectangle, and this is a good demonstration of how a nested loop works. So let's begin then. Step one is that we're going to accept a character from the user, and then we're going to print a single line depending on what the user types in for a width. And then after we complete that program, we'll upgrade it to printing out a rectangle like it has two different dimensions. So let's create a char variable, and we'll call this perhaps symbol. And we will want a integer variable named perhaps width. And then later on, when we upgrade this program to a 2D rectangle, we'll include length. All right, so we'll create a display, and we will have a prompt that says enter the symbol to use. And then we will see in whatever the symbol the user types in. Okay? And we are going to see out enter the width. And then we will see in whatever the width the user types in. All right, so we'll create a for loop. And then later on, we'll turn this into a nested loop. So we'll need some sort of index or counter. The standard programming practice is to have a integer variable named I, and we'll set this equal to 0, and then add a semicolon at the end. So remember, there's three statements within this for loop. The first is declaring an index or counter of some sort. Second is the condition. So we want this for loop to iterate depending on what the width is. So we can just simply say we're going to continue this for loop as long as I is less than whatever our width is, semicolon. And lastly, we want to increment our index, so we can just type in I++. So what do we want to do during each iteration of this for loop? We want to display, so see out whatever our symbol is that the user types in. Okay, so let's run this program to test it. So this is only going to print a single line. Enter the symbol to use. How about a money symbol? Enter the width. How about 5 money symbols? All right, so we ended up with a single line, and the width was 5, and this just prints a single line of characters. Now let's turn this into a program that will display a rectangle. So we're going to add a height. So integer height, and we will create a prompt to enter the height, and we're going to change width to height for this line here. All right, so what we're going to do now is that we're going to surround this for loop with another for loop, and this outer for loop is going to be in charge of keeping track of the height of our rectangle. So we're going to take these curly brackets and surround this for loop. So now we have an outer for loop and an inner for loop. So this is now a nested loop. So this outer for loop is going to be in charge of the height of the rectangle. So it's going to be a similar process to what we have with these three statements within the inner for loop. One thing though is that with standard programming practice with nested loops, they usually use a index or counter called j. And the reason that I think that they use this is because typically the default is I for an index, and I think they use j as the next one just because it comes next in the alphabet. That's my reasoning behind it. So it's going to be the same process as before. Int I equals 0, semicolon. And we're going to continue this outer for loop as long as I is less than our height, semicolon. And lastly, we're going to increment our I counter. After we exit this inner for loop, we would like to move down to the next line. Think of it like a typewriter. So after we complete one line, we would like to go down to the next line. So a simple way to do that here is that we can just C out ENDL to move down to the next line, as if it's like a typewriter or maybe a 3D printer. We'll finish printing one line, and then we will jump down to the next line and just continue the cycle until we can escape the outer for loop. So let's run this program to try it. So enter the symbol to use. This time let's try the @ sign. Enter the width, perhaps 10, and the height, maybe 12. All right, so here's our rectangle. So let's just check to see that this is accurate. So width of 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Height of 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, that works just fine then. So this is a fun little program you can do to create or print a rectangle with a symbol, width, and a height that you specify. So that's basically how nested loops work. It's just this general concept of having one loop that's inside of another loop, and you're not limited to just having one inner loop and one outer loop. For example, we could take this a step further and put this all within another loop, and it's kind of like we would have 3 different levels then. We have an inner loop, a middle loop, and then an outer loop. I can't really think of any practical applications for 3 different levels of loops, but I'm sure they're out there though. Really for this tutorial series, we'll only be dealing with like 2 levels at the very most, I would say. But this could be useful for maybe printing some sort of like 2D layout or something. And when we get to this topic on 2D arrays, these nested loops are actually going to come in handy to display all these elements of like a chart basically. If you need to take anything away from this, basically just a nested loop is one loop that's inside of another. We will cycle through the inner loop, and once we exit the inner loop, then we will complete one cycle of the outer loop and restart the process all over again. Oh, and a quick note that I forgot to mention when originally filming this video is that with nested loops, you're not required to have for loops. For example, you could have a set of while loops. Of course, you would have to have different statements. You couldn't have these 3 statements. You would have to have like a single condition. But yeah, you can mix it up. You can have nested loops that are while loops or for loops or a combination of for loops and while loops. It doesn't matter. Just for this example, we used for loops for the inner loop and the outer loop. If you're having some trouble understanding this concept of nested loops, don't worry, we'll be revisiting this topic again when we get to 2D arrays, and we won't really be using these anytime too soon, I would say. So you have some time to actually play around with these, but that's pretty much this lesson on nested loops. If you would like a copy of this program, I'll post all of this code in the comments down below and pin it to the top. If you're looking for additional practice or a project to work on, why don't you create a program that involves a nested loop and post it in the comments down below, because I would like to see it as well. But yeah, that is this topic on nested loops in C++. What's going on, everybody? It's Bro here. Hope you're doing well. And in this video, we're going to be discussing the printf function in C++. Let's get into it. Before we begin this lesson, just so you know, this lesson is optional. We won't really be using the printf function too much, but it's something you might want to consider for your own future programs. So let's begin. All the printf function is that it acts as a control for displaying our output a certain way. For example, this might be useful for maybe some sort of cash register program, and if you add a bunch of numbers together or use a coupon, you might get a result like $100 and 25.5 cents. So when you display this number, you probably don't want 3 decimal places because, well, that doesn't really work for currency. So we can use the printf function to truncate the last decimal or only display 2 decimal places when we produce output. Otherwise, if we're working with columns of data, we can do things like line up all of our columns together and add a certain amount of spaces before our information is displayed. So this could be useful if you're displaying like tabular data or columns of data too. So we can do unique things like this involving the printf function. So let's practice by creating some variables related to cars. Well, because I like cars. So let's create a few variables. So maybe we'll make a make, that's a string, a model, an integer named year, a double value named price, and we need a char value. So perhaps maybe a variable named for sale. So if you have your own favorite car in mind, feel free to assign some of these variables with your favorite car. I will assign some of these variables with my favorite car, so come up with your own or copy me. Doesn't matter. So for the make, it's going to be Ford. The model is going to be Mustang. The year is going to be 2021. The price, oh, make sure that this is not within quotes. All right, we're good then. $9,999.000. And for sale, this is a single character. So we could put like Y for yes or N for no. It doesn't necessarily have to be those two, but I guess that would make sense. All right, so let's use the printf function to display some of this information. So to use the printf function, all you do is type in printf, then you need a set of parentheses, and let's add a semicolon to the end before I forget. Now we can add a format string within the parentheses. So perhaps I will say, your car is made by. All right, now we can insert a value or variable, and we're going to insert it wherever we place a percent sign. So this begins the format specifier, and we can add a value or variable that we want to display, but we have to separate it with a comma. Then we're going to put our value or variable here. So to begin, we're just going to display the word Ford, not the variable, just the string literal. All right, so now with this format specifier, this percent sign will begin this, and this variable or value will be inserted right where this percent sign is. And there's a certain combination of values and characters we can add after this percent sign, and each of these is going to have a particular effect on how our output is displayed. So here's a chart that I made. Let's take a look. All right, well, here's a little cheat sheet that I made. So we begin the format specifier with a percent sign, and at the end, we need to list the data type of what value or variable that we want to display. So there's going to be a certain character we're going to add here to display certain information. For example, if we want to display a string, we're going to put S here. And if we're going to display a character, this would be C. And there's a few others, and we'll cover those in just a moment. So there's other optional fields that we can add that will edit the width, the precision, the length, and there's certain flags too, and we'll cover those in just a moment. So to begin, let's cover just the different format specifiers we can use for data types. And then once we get the hang of that, we'll cover flags, width, precision, and length. Let's head back to our program. So if we want to display a string literal where this format specifier is, after the percent sign, we just type in the letter S to display a string. Let's see what this looks like when we run it. Okay, your car is made by Ford. Let's try another example. So what I'm going to do is just C out ENDL to move down to the next line. You could put \n for a new line, but I don't want things to get too complicated in this area. So I'm just going to add a new line after our printf function. So what would happen if we did the same exact thing, but instead of a string literal, we used a string variable? So this is what the result is going to be. And I'm just going to copy and paste this, but we're going to change this string literal to a variable. So we can use the variable make. And pay attention to see what happens here. All right, so our car is made by Ford, and this time we used a string variable, and we actually got an unexpected result. And let's run this one more time, and this should actually change again. Here's the problem with string variables and the printf function. So the printf function was designed to work with the C language, but it doesn't have the built-in data type of string. And if you were to use this, you would get an unexpected result. So one trick that I found is that there's a way around this if you want to display a string variable in your printf function in place of a string literal. This is what you can do. After the string variable, just type in .c underscore, then use the str function. So you need a set of parentheses here. So what this does is that it returns a pointer to an array that contains a null terminated sequence of characters representing the current value of the string object. So basically what that means is that this function will return whatever value is at this variable. So these should work the same now if we were to run this. So your car is made by Ford, your car is made by Ford. So just keep that in mind. If you're using the printf function to display a string variable, you'll want to use this function after the variable name. Otherwise, if you're using a string literal, you could just type that here. Another trick is that with the printf format string, you can add multiple format specifiers if you want to include multiple values or variables. So let's display the make and the model in one single string. So printf, your car is maybe a colon. All right, so we want to display the make and the model, but let's display the string literals first, and then in the next example, we'll do the variables. So we want to display the make, so %s because it's a string. Now we also want to display the model, so we can add another format specifier here, and we'll display another string, so %s. Now after the format string, we're going to add two values. So the first one, it needs to be separated with a comma. We're just going to type in a string literal, Ford. Now we need another string to add, so we're going to add another comma, and then type in our model, which is Mustang. And then let's add a semicolon at the end. Okay, so then this will display two strings, so we can add multiple format specifiers to a single formatted string. So your car is a Ford Mustang. So with these format specifiers, it's as if we're inserting this value or variable wherever this format specifier is located, and it's in order. So the first format specifier is going to be assigned with the first value, and the second one is going to be assigned with the second value, so on and so forth in that pattern. So if we had three format specifiers, we would need a third value or variable here. So let's try the same thing, but we're going to assign the string variables in place of these. So I'm just going to move down to the next line by saying cout endl, and let's try the same thing, but we're going to use the variables this time. So printf, your car is a colon space. We need the first format specifier, so %s, and the second, so %s again. So we want the make first, so make dot c underscore str, then a set of parentheses. Now we want the model, so model dot c underscore str, then a set of parentheses. And I am missing a semicolon at the end. All right, let's run this to see if it works. Your car is a Ford Mustang. Your car is a Ford Mustang. All right, so I think we got string format specifiers down then. And before we move on to the next example, I'm just going to move down to the next line. And I think I'm going to make this a little more organized. So I'm just going to line these up. Okay, that should be good. Let's display the year, which is an integer variable. So printf, then we need a format string. The year is, so if we want to include a integer variable, we need to use the % format specifier. Then we're going to put the letter D here, and then we'll need to insert a comma, then the value or variable. So if you're inserting an integer variable, a double variable, or a character variable, basically anything but a string, you actually don't need to use this function, because with the C programming language, these string variables really aren't compatible with the printf function. But if you're using a primitive data type like a integer, a floating point number, or a char value, you don't need to use this function. So we could just use this variable and this would work just fine then. So the year is %decimal. The year is 2021. So I'm going to move down to the next line just by typing cout endl. Let's display the price. So printf, the price is, if we want to display a double or floating point number, we're going to put %f for floating point number, comma, then our price variable, cout endl. Not necessary, but I want to move down to the next line after this. There. All right, so if we want to display a double variable or a floating point number, we just use %f for floating point number. So the price is $9,999.00000000. So we're actually going to be formatting this fairly soon. Now, if we want to include a char value, it's going to be a similar process. So printf, then a formatted string. Is it for sale? %C to display a char value, then a comma, then the variable will go here. So for underscore sale, cout endl. Okay, is it for sale? Yes. So remember that if you're using a primitive data type or variable when using the printf function, you don't need to use this C_str function. But if you're using a string variable here for your printf function, then you would need to use this to return whatever value is located at this variable. Well, I think we have the different data types down with using the printf function. Let's cover a few of the flags, the width fields, and the precision fields that we can use to format our output. For the next example, let's try and display the price, but we're going to limit the amount of decimal places that are displayed because that would accurately reflect a price instead of 3 decimal portions. So if we want to display a floating point number or a double number of some sort, we'll use the %f format specifier. So the price is, so normally we would type in %f, then a comma, then our price. However, if we want to limit the amount of decimal places that are displayed, we're going to type this after the %, but before the f, .2 to limit this to 2 decimal places. So let's see what this looks like right now. Yeah, the price is $9,999.00, so 0 cents. But you know what? I think I want a $sign, so I'm going to add that before the format specifier. So let's try that now. Yep, $9,999.00. All right, now we can have our output be preceded with blank spaces, kind of like we're hitting tab. So what we're going to type is printf, and maybe I'll just add a note this time. This precedes with blank spaces. And maybe we'll display a string, so %s. And let's add a string literal, like whatever the make of the car was, and that was Ford. Then colon, cout, endl. All right, so we can specify or allocate a certain amount of space to actually display whatever value is here. Let's say that we want to give our string, our formatted string, 10 spaces to work with and actually display this information where our format specifier is. So after the %, but before the data type, we're going to type in however much space we want to give this value to display. So we could say maybe 10. We can pick a different amount too. So what happens is that if we were to run this, we would actually have all of this blank space before displaying our value. But let's count how many spaces are here. So we have 1, 2, 3, 4, 5, 6. And we actually don't apparently have 10. That's because we're actually including the space that the value takes up too. So altogether we would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you're basically giving or assigning room to actually display your value. So this would be really useful if you're displaying like a column of information and you want things to be lined up naturally. So that would be a good use to precede some information with some blank spaces. And you can have your value be preceded with zeros. So what I'm going to do is just copy this, and we're going to make one change. So after the % in the format specifier, but before the amount of space we want to have this proceed with, we're just going to put 0. And I'm just going to change this string here. This proceeds with zeros. All right. Yep, here's all of the zeros. And we should still have 10 spaces of room assigned to displaying this value. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think lastly for this video, I'm just going to show you guys one flag that you can use to left justify any value within any space allocated using the printf function. So what I'm going to do is just copy this line that says this proceeds with blank spaces, and we're just going to make one minor change. So if we want to left justify this value, because normally it is right justified, so any extra space is assigned before the actual value is displayed. If we want to left justify it, we're just going to add a minus sign, so % minus the amount of room that we want to give this value to display, and then the data type of the value. So this, we should probably change this message. Maybe we'll just type in left justify. All right, so let's see what this looks like right now. So it says left justify, then the make of our car, but we have all of this blank space after, but we can't really see it right now. So let's add another format specifier to display after this. I'm just going to copy this. So we're just going to add % minus 10s, and then we'll add a make or a model for the car. So we'll just add Mustang. So let's try this again. So it should be a parrot now. Yeah, that's fairly clear. So now we have 10 spaces to work with. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the value is now left justified within the space that we gave to display our value. And the same thing is going to be with the other string that we assigned here as well, but it's not as apparent here. But just pretend that all this room is here. Well, that's the basics of the printf function. I do apologize for this long video. This was a fairly difficult topic to cover, but if you would like to learn more, I'll include a link in the description for the C++ website where you can learn more information about this. There's still more flags and different values you can add to your format specifier for different effects, but these are just a few of the basics. And I'll include all of this code in the comments down below and pin it to the top if you would like a copy for yourself. But yeah, those are the basics of the printf function in C++. Hey, it's your bro. Hope you're doing well. And in this video, I'm going to show you guys how you can create your own custom functions in C++. So let's get into it. Well, us programmers, we like to reuse code when available and not have to repeat it unless it's necessary. So you may encounter a situation where you find yourself repeating some code more times than what you would like. So what if I told you there was a way where you can write some code only once and then you can call or reuse that code whenever you want? Well, that's the benefit of a function, and we're actually familiar with a few functions already. In the last lesson, we learned about the printf function. Another that comes to mind is the length function. Another is the at function. And you may notice that these tend to end with a set of parentheses. So with functions, they perform some sort of task for us. So what I'm going to teach you guys is how to create your own custom function to perform some task for you whenever you call it. So I have an idea. Let's create a function that will display a greeting for us. So this is the first step you'll want to do in order to create a function. We're going to create this function before your main method, and we're going to type in the word void. And then we need to come up with a name for this function. And your name should reflect the task that it performs. If we're creating a welcome message, we can simply name this function maybe welcome. And there's a common naming convention with functions. You'll want to be sure that the first letter is lowercase. Then we'll need a set of parentheses and then a semicolon. So this is step one. We have declared a function. But step two is that we want to define what it does. So we can do that just by adding a set of curly brackets after the parentheses, but before the semicolon. That's good enough. So we're going to write whatever we want this function to do when it's called within the curly braces, so we can perform some sort of maybe message to display. So we can see out, welcome to my program. Okay, we have successfully created a function named welcome. When we call it, it's going to do this, whatever's between the set of curly braces here. Now, going back to our main method, we can call this function whenever we want to perform this task. And in this instance, we're just displaying one line of code or one message. So in order to call a function, we're going to type in the name of the function, followed by a set of parentheses, and then a semicolon at the end. So we will perform this task every time we call this function. So let's try it. Yep, welcome to my program, just like we anticipated. Now, we can keep on reusing this code too. Perhaps I want to display a second message. Well, I'm just going to call the welcome function one more time. So this will actually display this message twice then. Welcome to my program, welcome to my program. But I should probably add an end line after this, just to make it look better. Okay, so that's the basics of creating a function. Let's create another that displays a goodbye message. So it's going to be the same process as before. So void, maybe we'll call this goodbye, set of parentheses, then a set of curly braces, then a semicolon. All right, and then we will display a message that says goodbye, ENDL. All right, so we have two functions now, one named welcome and another named goodbye. We can call either of these functions whenever we want in our program. So for our example, we'll call the welcome function, and then we can call the goodbye function. So goodbye, parentheses, semicolon. Let's try this. Yep, welcome to my program, goodbye. Well, I believe we have the basics down for declaring and defining a very simple function, but let's take it a step further. Let's take it to level 2. Now, when you call a function, you can also send that function some information. This can be a value, a variable, or even an object. For example, let's say that we want to send a name to our welcome function, and that welcome function can do something with that name. For example, we can display a name that we send it along with our greeting. So if you want to send a function some information, when you call that function, you're going to place whatever values you want to send that function within the parentheses. Let's send our welcome function maybe a first name. So I'm just going to type in my first name as a string literal within the parentheses when we call this function. So whenever you send a function some information, these are called arguments. It's the information that you're sending a function. Think of it like mail. The mail or the letter that you're going to be sending is also referred to as an argument. All right, so this is step 1. Step 2 with sending an argument to a function is that the function needs to be set up to actually receive this argument. And this is done by setting the parameters of the function. So within the parentheses of your function definition, what we're going to do is that we are going to list the parameters of what we want this function to receive. If we want to receive a string that's going to function as a name, we're going to write the data type of this argument, followed by a unique name for this value. So we can just name this name. All right, so you can see that the red squiggle went away. So we can now send a string that will function as a name to our welcome function, kind of like we're sending mail to this function. And this function is going to take this name and it can do something with it. So we could actually display our name along with the welcome message. So I'm just going to add that here, and this should work just fine then. So let's try it. Welcome to my program, bro. Now, whenever you call a function and it has a set of parameters, you need to send a matching set of arguments when you call this function. For example, if I were to take out this first name, the string that I had here, and attempted to call this function, well, there's not a matching set of parameters and arguments when we call this function. So this would result in an error then. So we can't actually do this unless we were to send some sort of string to this function. So let's take this a step further. Let's accept some user input, and this time we're going to send two arguments, maybe a string and then maybe an age. So this will be an integer variable, so we need to list the data type here, and then we will call this age. So we can no longer just send a string, we also need to send a integer as well. So maybe I'll just type in 18. So make sure that each argument is separated with a comma. So let's change our program around a little bit. So I'm going to copy this and paste it, and I will just type in you are age years old. But there we go. And now we have a matching set of arguments and parameters. So now we can call this function and perform this task for us. So let's try it. Welcome to my program, bro. You are 18, yo. Goodbye. Now we can send some variables and not just some hard values to a function. And let's accept some user input from the user. So we're going to declare a string variable named name and an integer variable named perhaps age. And we will provide a prompt for the user to type these in. Enter your name, then get line cin, comma, name, just in case they type in a last name. But I'm forgetting a semicolon there. All right, and we will do the same thing with age. So cout, enter your age, endl, semicolon, cin, age. All right, and now we can actually place variables here because they're going to store whatever values that we assign to them. So we're going to place a name variable and the age variable. All right, this should work now. Let's try it. Enter your name, bro, Washington. Enter your age, 107. Welcome to my program, bro, Washington. You are 107 years old. Oh, and one quick note, if you're sending some variables over to a function, they do not have to have the same name. So for example, I have name and age here that we're sending our function. We can actually rename these when we receive them. So for example, I could change this to username and user age. Then you'd have to change it here too if you use them. So username and user age. And this would work just the same then. So they don't have to have the same exact variable name if you send some variables over. You can rename these. All right, let's take it a step further. Let's go to level 4 with functions. At least I think we're on level 4. So we can have a function return something. So normally we have these set to void. This keyword is the return type, and we're not currently returning anything when we call a function. So I think it would be best if we started a whole new program, and if you want a copy of this, I'll post it in the comments down below, so don't worry. But I think it would be best if we were to start fresh then. Well, I have an idea. Let's create a program that will accept two numbers from a user, and we will take those two numbers, send them to a function. The function will add them together and return the result. So let's begin that program here. Let's create two values, and these can be double variables. So double number 1 and double number 2. C out, we'll create a prompt to enter in the first number. Enter in number 1. Okay, then C in number 1. And let's do the same thing with number 2. Enter in number 2 and C in number 2. Not 3, 2. We're good. All right, so let's create a function that is named add, and we're going to send 2 double variables as arguments. All right, so now we need to create this function called add. So before, when we typed in void, this is the return type. So we want this function to return a result. So we need to list the data type of what we're returning here. So we're going to be returning a double value. So instead of void, we're going to type in double because we're returning a double value. Then we're going to list the name of the function, and we need to set up the parameters. So we're going to receive a double value. So we list the data type here, and we will call this maybe num1. Then we need to set up a second parameter. So this is going to be double num2. Let's define this function. So a set of curly braces and then a semicolon. So what do we want this function to do? We're going to add these two numbers together. We could call this double result. We're going to declare and assign this variable right away. So num1 plus num2. All right, lastly, we just need to return the result back to this method call, this function call. So at the end of your function, we're going to return whatever we want. We're going to return our variable result. All right. So now when we call this function, it's going to add these two numbers together and it's going to return a result, but we need to do something with that result. So here, I'm just going to create a new variable. We can call this double result equals whatever there is returned here when we call this function. And lastly, let's just display our output, our result. So cout, your result is result ENDL. Okay, let's try this then. Enter in number 1, 3.5. Enter in number 2, 7.1. Your result is 10.6. Yeah, that seems right. All right, so that's what you do to return a value. Instead of using that void keyword, you write down the data type of what you're returning exactly. So just to reinforce this idea of returning a value, if you call a function and it returns a value, there's a data type when you define this function. The data type when you define this function has to match the data type of the value that you're returning. So if our variable result was maybe an integer, we would want to change the return type when we define this function to also be an integer. Or if this was a string value, we would also change the data type in our definition to be a string as well. So make sure that the value you're returning and the data type in the definition also match. And my last tip for today is that if you are declaring a function, you need to be sure to declare it before the main method, because our programs work from the top and work their way down. So if I were to move this declaration for this function and moved it to the end, this would actually not work then. We'll get an error. And you can see that here. So another trick is that for some reason, if you do want your definition for your function to be after the main method, you can actually simply just declare the function and not actually give a definition for it yet. So you do need a definition before the main method. So we'll write that here. So that was double add, and then we needed a set of parentheses, and there were two parameters, double num1 and double num2. And then we're not going to add a set of curly braces, we're just going to add a semicolon. So this would work then. Yeah, you can see it here. It looks like it's working just fine. So with your own program, if you really want the definition to be after the main method, you can do that, but you'll want to be sure you're at least declaring this function before the main method at least. But otherwise, it depends on how you want your program organized. I tend to just declare and define my functions before the main method. So do whatever works for you then, but I thought I would just mention that. So that's the basics of creating functions. If you would like a copy of the code we worked on today, I'll include all of this in the comments down below, both the first example and the second example that we both worked on. And if you're looking for additional practice or a project to work on, why don't you create your own function and post it in the comments down below. But yeah, that is how you can create your own custom functions in C++. Hey, how's it going everybody? It's your bro here, hope you're doing well, and in this video we're going to be discussing overloaded functions in C++, and at the end of this video we're going to be using overloaded functions to bake some pizzas. So, let's get into it. So basically speaking, overloaded functions is this concept that you can reuse a function's name as long as it has different parameters set up, and for this example I have two functions both named bake pizza. And this is legal because each of these has different parameters. This first function accepts one argument as string bread, and the other has two parameter setup that accepts two arguments, bread and a sauce. So this is actually legal then, but if these two parameters for each of these functions was the same, this would result in errors then. So let's try and compile this and run it. So it says, there were build errors. Would you like to continue? No, I don't. So this obviously doesn't work, but if we were to have different parameters set up, this is actually legal then. And you can see that it's already compiling with no problems, although it doesn't do anything yet. So let's create a program where we will have different overloaded functions and we can pass in varying amounts of ingredients as arguments. So let's begin fresh then. Let's create a few variables related to pizzas. So we'll need a bread of some sort, and we'll assign this later, the values to each of these variables. We'll need a string, sauce, string, cheese, no pun intended, string, and a topping. All right, now let's create 4 different functions all named bake pizza. So let's begin with a function that takes all 4 ingredients as arguments. So this won't return anything. We'll just say void bake pizza. Then for the parameters, we're going to set up 4 different fields: string bread, comma, string sauce, string cheese, and string topping. And then maybe we'll just display all the ingredients. So maybe we'll just see out, here is your, then we'll list all the ingredients for this pizza. See out bread. I'll probably add a space between these two. See out sauce, space. See out cheese. And lastly, see out, what was it, a topping? Yeah. And then we'll just display the word pizza here at the end. So, pizza. Okay, so that should be good then. Now we just need to copy this, and then we're going to create another function with the same name, but a different set of parameters. Like this one won't have any toppings at all, so we'll just take that out, and we'll take that out here as well. All right, then we'll copy this, paste it again, and this time we will take out the cheese then. And seriously, who orders pizza without cheese? All right, and then just plain bread, I guess, which is kind of silly. All right, so we have 4 overloaded functions with for this function named bake pizza then. So now we can actually pass in some ingredients, but we'll probably want to assign these. So for a bread, maybe we'll say thick crust. And for a sauce, I don't really know many sauce names, maybe marinara. Actually, red sauce is probably a more accurate term. mozzarella. I really don't know how to spell this. And then toppings, what about pepperoni? Okay, so we have a bunch of ingredients set up. Now we can call the bake pizza function and send basically any of these values here as arguments. So let's say we only want bread, sauce, and cheese. Well, this will actually pass all of these as arguments then, and it will perform whatever code is within each of these functions then. So let's try it now. So let me expand this a little bit. Here is your thick crust marinara mozzarella pizza. Now we can pass in the topping, but spell it right. Here is your thick crust marinara mozzarella pepperoni pizza, and then we could do just the bread too. Yep, here is your thick crust pizza. I just realized that I had a space before the word pizza, and I didn't feel like refilming this whole video just to go back and correct that. So basically, with overloaded functions, you can reuse the same function name as long as each of these functions has different parameters set up. So this is fairly convenient because you can just call one function and pass in varying arguments depending on what you need. So for our bake pizza example, we can send whatever ingredients we want, and we don't need multiple bake pizza functions, like we don't need bake pizza 1, bake pizza 2, bake pizza 3, so on and so forth. We can just say bake pizza and then pass in the arguments that we want. But yeah, that's the basics of overloaded functions. If you would like a copy of this code, I'll post it in the comments down below. If you have a program that you're working on that involves overloaded functions, feel free to post that in the comments if you want to share it. But yeah, that's the basics of overloaded functions in C++. Hey, what's going on everybody? It's your bro here, and in this video I'm going to teach you guys how to create your own random numbers in C++. So let's get started. Hey everyone, so we're going to be discussing generating random numbers in C++, but I do have a disclaimer. These are not true random numbers, but something called pseudo-random numbers, which are very close. So using pseudo-random numbers would be fine if you're making a simple game in C++, if you need to simply roll a dice or deal some cards, but I wouldn't use these for any like high-level program that involves some security, but this would be fine just for a simple game. So let's begin. Now, at the top of your program, this is what we're going to include. We're going to include two things. So include stdlib.h, and this is for the srand as well as the rand function. The other thing that we're going to include is time.h, and this allows us to work with the current time. All right. So the first step to creating a pseudo-random number is that we are going to initialize a random seed based on the current time. This is what we can do to do that. Type in srand, then a set of parentheses, and within the parentheses type in time, another set of parentheses, and the word null. So this is going to generate a random seed for us, and it's going to change based on the current time. There are other techniques of generating random seeds for pseudo-random numbers, but this is one that you'll commonly see, so that's why I'm introducing this method instead of others. Alright, now we want to assign a random number to a variable, so we'll declare a variable such as number, and we're going to set this to rand, parentheses. Alright, and this next part is we're going to type in modulus and the range of numbers that we want to generate. So let's pretend that we want to roll a 6-sided dice. We're going to type in modulus, then 6, all right? So we're going to get a random number between 0 and 5, but it's a total of 6 numbers. So you always count 0 when you're generating a random number. So if you want the numbers 1 through 6, one thing you can do is just add 1. So this will generate a random number between 1 and 6 for us. So let's actually display this just to test it. So we're going to see out whatever our number is. So let's run this. Okay, we got 1. Let's try it again. 5, and 1 last time, and 5 again. All right, so we know that it's working then. So if you want to change this to a different number, you can. So for example, I play a lot of Dungeons and Dragons, so we use polyhedral dice that might have like 20 sides or 12 sides. So if you want to roll a 20-sided dice, I would just put 20 here and then plus 1. So then I'll get the numbers 1 through 20. So let's try this now as if we're rolling for initiative. So we just crit failed, we got a 1. Let's try it again. We got an 11, and we got a 20. So I have an exercise that we can work on. Let's generate 3 random numbers and display them, kind of like a slot machine, but without all the fancy pictures. So what I'm going to do is just copy this statement and paste this a few times, and I'm going to change these variables to number 1, number 2, and number 3. And maybe let's change the range from 1 through 10. And then I'll just display these. So number 1, maybe I'll add a space between here. Number 2, and add a space. And number 3. Okay, let's try this. We got 7, 3, and 10. 3, 9, and 7. And 3, 6, and 2. So this will generate 3 random numbers between the ranges of 1 and 10. And if you know how to work with GUI components or some sort of visual, you could easily just replace those numbers with some sort of picture or other like graphical image if you do want to simulate like a slot machine of some sort. But this would be a good place to start to at least get the random numbers going. So just a quick summary that when you use this random function, you can use modulus and the range of numbers that you want to generate. If you want 100 numbers, you could change this to 100, but it's going to be the numbers 0 through 99 that you get. So you can add like 1 to get 1 through 100. Otherwise, you can always add a higher number to this for some reason. Like you can add 10, then all numbers that you generate would have 10 added to them then at that point. So it depends on the program you're really working on too. So you can use modulus, the range of numbers that you want. Then if you want to add something to that number, you can do so. Well, that's the basics of generating random numbers in C++, but I'm going to walk you guys through how to create a guessing game if you're interested. So let's delete all this and start over. I'll include all of this in the comments down below, so don't feel like you missed out on it. So before we get started, you'll want to be sure to include these 2 things, std.lib.h and time.h if you haven't done so already. Now we'll need to declare a few variables. We'll make an integer that will be our number that we generate, an integer that will be our response, and an integer that will serve as some sort of score, and we're going to initialize this right away and set it to 0. Now we'll need to initialize a random seed based on the current time, so s random, then time, parentheses, null. All right. And for our number, we're going to set this equal to rand, parentheses, modulus, and then if we want a random number between 1 and 10, we can just put 10 here, plus 1. Otherwise, we can make this extreme and say like 100, so we have to guess a random number between 1 and 100, but let's start with 10 for now and keep it simple. All right, the next step, we're going to put all of this within a do-while loop. So do, then a set of curly brackets, and while, then our condition. So the condition is that we're going to continue guessing as long as our number does not equal whatever our response is. So there's a few lines that we're going to fill out within the do-while loop. The first thing that we're going to do is prompt the user to enter in your first guess. Enter your guess. 1 through 10. All right, then we will see in whatever the response is. Then we're going to use a few different if statements. So if our response is greater than the random number, what we're going to do here is see out that was too high. Okay, so then else if the response is less than the number, we will see out that was too low. All right, then lastly, we're going to put an else here because if the response is not greater than the number and the response is not less than the number, then the response must be equal to the number. So then we will type see out that was correct. And I think I'm just missing a semicolon here. And after the else statement, we're going to increment our score counter by 1. Then I also need a semicolon after the while loop here as well. All right, so then after we escape or exit the do while loop, we'll want to display the results. So I'm just going to see out number is whatever the number was, and then see out the amount of guesses that it took us. So we'll see out our score. And I think I'm going to add a new line before this just to give us some space. You know what? I'm going to add a new line character here by guesses and after each of these see out statements as well, because I forgot to do that. Okay, let's run this now. Okay, enter your guess 1 through 10. I'll guess 5 because it's near the middle. That was too high. Let's try maybe 3. That was still too high. 1. That was too low, so I'm guessing it's 2 then. All right, that was correct. The number was 2, and it took us 4 guesses. 1, 2, 3, 4. Let's try it one more time just to be sure it's working. So enter your guess. Let's try 6. That was too high. Maybe 3. That was too low. How about 5? That was too high. And 4. That was correct. The number is 4, and it took 4 guesses. All right, so that is a very basic guessing game. So that's the basics on random numbers in C++. If you would like a copy of all this code, I'll post it in the comments down below and pin it to the top. But yeah, that's the basics of pseudo-random numbers in C++. Hey, what's going on everybody? It's your bro here, and in this video I'm going to teach you guys how pointers work in C++. So let's get into it. So basically, whenever we declare a variable, that variable has an address in your computer's memory where this value of that variable is going to be stored. So pointers are necessary for dynamic memory allocation, and that can't be performed without them. So we'll be using pointers for a project when we cover the topic on arrays and how they can be useful. So let's begin by creating a few variables, and I'll show you how this works. I already have one string variable named name, and I assign this a value of bro. Let's create another, maybe an integer variable named age, and I will assign this a value of maybe 100. I am 100 years old. And let's display these using a cout statement. So we'll cout name, and then add an end line after, and cout age. And we'll also add an end line after this as well. So this, as you would expect, will display the word bro and the number 100. So now there's this ampersand symbol that you can add to a variable, and this is called the reference operator, also known as an address of operator. I've heard people call it both things. So this will return a variable's address in memory, as in the street address in RAM where it's currently located. So let's run this and see what happens now. Alright, so we get these two funky numbers. The first one is for our first variable, and the second one is for our second variable, age. So think of this like your own street address for wherever you live. For example, like 123 Fake Street, except this number is the address for wherever this value is stored. Well, this number is kind of the same thing, but instead of a street address, it's the street address in your computer's memory where you can find this value. It's the location in RAM of this variable. And one thing that you may notice that every time we compile and run this program, the address may change. So these addresses are really only temporary. Now, you don't even need to assign these variables a value. Just by declaring these variables, you're already creating an address of where these variables are going to store a value. So let's run this again, but we're not going to assign a value. So you can see that these variables, even though they do not store a value, they're only declared, we still have space for them to actually store a value at these addresses in our computer's memory. Now, the next step is that we can store an address in a separate variable, and that is what's called a pointer. A pointer is a variable that stores the address of another variable, and to create a pointer, we need to declare a pointer, just like we do with other variables or constants. So this is what you do to create a pointer. So let's clear out what we have now and start fresh. So let's create a string variable named name. You know what, I guess we could have kept this line, but too late, I already deleted it. And an integer variable named age, and I will set this back to 100. Now, these are the steps to create a pointer. Now, the first step is that if we're going to create a pointer for a variable, we first need to list the data type of the variable that we're going to create a pointer of. If we're going to create a pointer of this variable name, that's a string, we're going to declare this as a string. The second step is that we're going to list an asterisk. And this is known as a dereference operator, and it returns the location value of a variable. Now we need a unique name for this pointer. A common naming convention is that you take the name of the variable, and you add a p before it, and you take the first character of that variable and make it uppercase. Other names would still work. That's just one naming convention. So this is basically the pointer for our name variable. And we're going to set this equal to ampersand name, which is the address of our name variable. And pname is now a pointer for this variable. So let's do the same thing with our age then, following the same rules. So we need to list the data type of this other variable, which is an int for integer, an asterisk, so we're using the dereference operator. Then let's create a name for this pointer. So I'm just going to type in age, add p before it, and change the first letter to capital. So ph for pointer age. And we'll set this equal to the ampersand and then age. All right, so we have made 2 pointers, and let's actually display these just to prove that I'm not a liar. So we're going to see out p name, then maybe endl, and see out p age, endl as well. So what you get here is that these pointers are going to display the addresses of these variables then. Yeah, that seems like it works then. So one thing to keep in mind is that if you display the dereference operator along with these pointers, it actually is going to display the value at these addresses. So we got our values bro and 100, and that kind of defeats the purpose. So if you're working with these pointers or you're displaying them, make sure that you don't also include the dereference operators. So let's create one more pointer just for practice. I'll create a string variable. Maybe we'll call this food equals, and then list your favorite food here. For me, that's pizza. All right, so we have a variable named food. I want to create a pointer for this, so we need to type in the data type, so string, use the dereference operator. Then we're going to create a new name for this pointer, p food equals ampersand, then the name of our variable, so food, and let's display this. So cout p food endl. And here is the address that is contained within our pointer pfood for our variable food. So these pointers may not seem too useful right now, but at least we know how to create them. They're used in dynamic memory allocation, and when we get to the topic of arrays, we're going to be creating a project where we will want some dynamic memory because it's really useful to have. So that's the basics of pointers. Hopefully this video gave you a few pointers as to how pointers work. If you would like a copy of all this code that we worked on, I'll post it in the comments down below. And if you're looking for additional practice, then in the comments section, post, how about 3 pointers that you created. But yeah, that is how pointers work in C++. Hey, how's it going everybody? It's Bro here, hope you're doing well, and in this video I'm going to teach you guys about arrays in C++, and at the end of this video we're going to work on a project where we can assign some names of cars and then place them all within an array, and then we're going to take this array, display all the values into some sort of virtual garage, kind of like this. Pretty cool, right? Let's get into it. All an array is that it's a variable that can store multiple values. So for example, I have a string variable named car, and it's storing a single string with the word Corvette. Now we can actually turn this into an array by following a few simple steps. So let's say that we want to add multiple car names to this variable. Well, we'll want to turn this into an array then. So the first step is that next to the variable name, add a set of straight brackets. And then all values that we want to assign to this array, we're going to surround with a set of curly braces. All right, so this is our first value. If we want to add a second value, we're going to separate each value with a comma, and then we can add maybe another car name. So think of this maybe like a parking lot or a garage. We're adding multiple cars to this array, and they're each going to take up one spot. So for the second car name, I think I will assign a Tesla. And the third, how about a Ferrari? All right, and then with the name of the array, you should pick a name that reflects the values that it's storing. So before we had a single variable named car, so I think I'll turn this into cars because it's plural now. So there we go, we have just made an array. Now there's one limitation with arrays. All the values that are assigned to this array have to be of the same data type. So for example, I couldn't mix an array with different data types. Like for example, let's get rid of this Ferrari and just add in the number 2021, like a year. Well, this would actually not work because we're mixing different data types. This is an integer and these are strings. So we have to be sure that we're only adding values of the same data type. Although we could add the string representation of the number 2021, this would technically work. Maybe we could change this to years, and we'll make this an array of integer values. So let's start adding some numbers. So like maybe 2020, 2021, and 2022. So this would work the same as well. With arrays, you have to make sure that all values are of the same data type. Now let's head back to our previous example of our array named cars. Now pay attention to what happens if I attempt to display this array named cars. All right, so take a look at this. We get this address, and you probably learned about this on the lesson on pointers. This is where this array is storing these values at this address. So if you want to display one of these values that's located in this array, you actually have to label the element. So what you want to do is that when you want to display one of these values, type in the name of the array, then that set of straight brackets, and then you're going to put the element number of the value that you want to retrieve. And if you want to retrieve, let's say, this first value, you're actually going to type 0. It's a computer science thing. Arrays always start at 0, and the next position would be 1, and then 2, and then you continue in that pattern. So if we want to display this word Corvette, or retrieve whatever is at this element, element number 0, we're going to type in the name of the array, followed by a set of straight brackets, and then the element number, which in this case is 0. So let's see what happens now. And it displays our first value, which is Corvette. So now let's say we want to display this second value. We're going to enter in element number 1 within the set of straight brackets. Let's run this just to test it. Yep, that's right. We have a Tesla in spot number 2, also known as element number 1. And then let's do the same thing with our last element here. So that is index number 2 or element number 2, and that has a Ferrari. Now, what happens if we attempt to retrieve an element that doesn't exist within our array? So let's say 3. So we don't have an element 3, we have element 0, 1, and 2. and this results in a problem. So an exception was thrown. It'll say something such as index out of bounds, and if we added another element to this array, we actually wouldn't have that problem then, so I think I'll add an Audi this time. And then let's display this. Yep. Oh, and another thing, with these arrays, you can always update these values. So let's say that we want to change that last element, element number 3. We're going to say cars, straight brackets, 3, equals, and then we can pick a new value. So maybe I'll place a, I don't know. I like Mustangs. Let's put a Mustang in there. And then let's display this again. So cars, 3, equals, Mustang. Yep, it's right there. Let's say that you want to display all the values in this array. Let me show you what you don't want to do. So what you don't want to do is simply just to see out all of these manually by hand. So for example, I'll just copy and paste this see out a few times. So if we want to display the first element, that is element number 0. The second one is 1, 2, and then 3. All right. So this would actually display all of them. But it's probably not the best programming practice to actually display all these. Let me show you a better method to display all the elements of an array using a for loop then. So let's start over fresh, but we'll keep our array of cars. So the first thing that we're going to do is create a for loop. So we're going to type for, then a set of parentheses, and then let's add a set of curly braces. Now there's 3 different statements that we're going to fill out within the parentheses of the for loop. We'll need some sort of index, so we'll say int I and set this equal to 0, then a semicolon to move on to the next statement. The second statement in our for loop is for our condition. How many times do we want this for loop to repeat and cycle? Well, we want this for loop to repeat for as many elements there are in our array of cars. So one way to write this is that our condition is going to be I is less than size, then a set of parentheses, and within the parentheses, we're going to type in our array name of cars. And then we're going to add a semicolon to move on to the next statement. So this is dynamic. So if we were to increase the amount of elements that are within our array, we wouldn't need to manually adjust how many times this for loop is going to repeat. When we compile this program, this number might update depending on whatever the current amount of elements is within our array. So we could freely add or remove elements without worrying about our for loop working or not. This is going to adjust. So for the third statement, we're just going to increment our counter. So we could just type in I plus plus. So now this for loop is going to repeat for as many elements there are in our array. So let's say that we want to display each of these elements now. So before, what we did is that we just typed in C out and then the name of our array, straight brackets, and then we put a number in here. So if we wanted the first element, that was element number 0, this would display the first element. Then the second one would be 1, 2, 3. So we would continue on like that. So what we're going to do within this for loop is actually put our index of I. So I is currently set to 0. So when we reach this part of the for loop, it's going to read cars at index I as in 0. And the second time that we cycle through this for loop, I is going to increment with this statement, and I is now 1, and it's going to continue after each cycle. So I'm just going to add an end line, and let's try this out now. All right, here is our array of cars then that we made. Let's try another example of this just so that we really have the fundamentals down of arrays. So I'm going to create another array of a different data type. So for cars, I'm just going to comment this out for now, and let's create a new array, maybe years. So let's make this of the integer data type. We're going to come up with a unique name for this array that reflects the values that it stores. So years, then a set of straight brackets, equals, and then we're going to add a bunch of values between this set of curly braces, and I'm just going to make up some years. So maybe 2021, 2022, 2000, 1999, 1842. All right, And then for our for loop, we're just going to change the word cars to years. So here and here. And let's try this. Yeah, that looks about right. We have 5 elements within this array called years, and they're all displayed here. Well, that's the very basics of arrays. I'll post this code in the comments down below. If you would like to take it a step further, I'm going to show you some more advanced stuff involving arrays. What we're going to do is dynamically allocate an array after the compilation phase by using a pointer. Don't worry, I'll walk you through it. So we will be able to ask the user for the size of an array and then have the user assign values to it. So we're actually going to make a project. We'll ask the user how many cars they have, and we're going to park each of their cars into an array. Think of it like a garage, and each element has a parking spot number. So if you want to continue, let's take it to level 2. Alright, well, if you're ready for some more advanced stuff, we're going to create a program that's going to ask the user how many cars they have. They're going to enter in some names of these cars, and we're going to put them all within an array that's going to function like a garage. And at the end, we're actually going to display all the cars that are within our garage, all the elements in our array. The first thing that we're going to do is to create an integer variable, and let's call this number. We're not going to assign this a value quite yet. We're only going to declare it because we're going to have the user type in a number for the number of cars that they have. So we're going to see out how many cars do you have? And then let's see in their response, and we'll store that within our variable number. This number is going to reflect how many cars they have, and this is going to function as the size of our array. Now, this is the tricky part. We're going to create a pointer for our array because we don't know how much space we need to allocate before the program actually compiles. So these are the steps. We're going to create a variable of strings. So we're going to type string, then we need to use the dereference operator, and we're going to create a pointer. So a common naming convention is to type in p lowercase and the name of the variable or the array, and the first letter is uppercase. So if this array is going to be named cars, we can just type in cars here with a capital C, equals new, then the data type that we're working with. So it's an array of strings, so we're going to type in string, a set of straight brackets. Okay, so then within the straight brackets, this is the amount of space that we want to give this array. We don't know how much space we're going to allocate. It's going to depend on this number. So if you were to type in 10, this would allocate 10 spaces, 5 would give 5 spaces. We're going to put in our variable number within here, and then add a semicolon at the end. So this is our pointer, pcars, for our array. All right, pcars is a pointer that's storing the address of our array, and when we assign values to this, we're sending values to whatever address is stored within our pointer. Now, we're going to create a for loop that's going to repeatedly ask the user for each name of each car they have for as many times as the number that they typed in. So let's create a for loop. So for, a set of parentheses, and then a set of curly braces. There's 3 statements to fill out within the for loop. We'll need some sort of counter or index. We can declare that within here, int I, and let's set this equal to 0, semicolon. The next statement is our condition. We could easily just say, we'll continue this for loop as long as I is less than whatever the number the user types in, semicolon. And then we're going to increment our counter by 1. Within the for loop, we're going to create a prompt for the user to enter in the name of each car that they have. So let's see out some sort of message. Enter car number, and then we will put the value or the index of I here. Now, one problem though, right now during our first iteration of the for loop, I is going to be 0, and if some user doesn't know any programming, and they probably won't, they'll be confused when it says enter car number 0. Like, what does that mean? So what we can do to actually offset the display for our index is just say I plus 1. All right, so this won't actually affect the value of 1. It's going to affect how it's displayed, though, to the user. So I is still going to be 0, but when it's displayed, it's going to be displayed as 1. So if somebody's using this program and it says enter car number 1, that actually makes sense. Before we had enter car number 0, where that probably wouldn't. We understand what it means, but the user might not. So we're going to say enter car number I plus 1. And then let's add a semicolon. And then we're going to cin. Actually, let's get line because some car names might have some spaces between them. So get line, cin, then comma. And then what we're going to type in here is the pointer that we made. So p cars at a specific index. So then we need a set of straight brackets. And then we're going to put our index or counter I within here. And then just add a semicolon at the end. Now with this for loop, it's going to have the user enter in a value for each car that they have, and it's going to assign this value at wherever this array is located, at wherever the pointer is pointing to, which is where our array is located. Now let's create some sort of graphical display to actually display all this information. So maybe we'll just make a cout message such as, here is your garage. And then maybe I'll create a new line after this, maybe before this as well, just to make it look nice. Maybe let's add like some sort of line here too. Then I'll create a new line. Okay, I think that's fine. And for this last step, all we need to do is to create another for loop that will display all the elements of this array this time. And honestly, we can just copy what we have here and simply paste it and make a few changes. All we need to do is to change the contents of this for loop. We can leave all of this the same then. So let's create some sort of display for each line. So maybe cout, maybe let's type in parking spot number. You don't have to do this exactly as I do. You can create your own sort of display. Parking spot number, maybe I, or you could do I plus 1. I think I'll do I plus 1. You could have a parking spot number 0 if it's like a VIP parking spot or something. Do what you want to do. So parking spot number 1, and then I think I'll add a space, and then I will display the element of each array. So if you want to do that, we're just going to type in p cars, straight brackets, and then our index, then semicolon. Oh, before we actually do run this, there's a few housekeeping things I'm going to add real quick. I forgot to end the line after this, and I'm also going to add a space after the number to make it look better. I'm kind of doing this on the fly, so the syntax isn't going to be perfect. All right, we should be good then. So there's one thing you're going to notice when we run this, and it's going to be fairly evident at first. All right, so how many cars do you have? Let's say 4, and then hit enter. All right, so you'll notice that it says enter car number 1, and then immediately it goes to enter car number 2. And this is the reason why. It actually skipped the first prompt for car number 1, and that's because when we typed in 4 and hit enter, well, cin picked up the 4, but when we hit enter, that's still within the buffer, and we need to get rid of that, because then when we used the getLine function here, it actually took the new line character and entered it into the first line of our array. So what we can do is actually clear the buffer. And what we'll do is after we type in cin number, we're just going to type in cin ignore and then just add a semicolon. So then that should clear the buffer then. So that's just one thing you might run into, and I wanted to point that out. Okay, now we should be good to go. All right, how many cars do you have? I have 4 cars. Enter car number 1. Let's say I have a Lamborghini. I don't know how to spell Lamborghini. I'll just type in Lambo. Car number 2, maybe a Tesla. Number 3, maybe an Audi. And number 4, perhaps a Jeep. All right, here is your garage. And here are the 4 cars that we have. They're all within our garage. And that is basically how you can create a program to dynamically ask for the size of an array and assign values to it to display. If you would like a copy of this program, I'll post all of this code in the comments down below. And if you're looking for additional practice, then why don't you create a program that involves an array and post it in the comments down below if you'd like to share it. But yeah, that's everything you need to know to get started with arrays in C++. Hey, how's it going, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to be teaching you guys about two-dimensional arrays in C++. And at the end of this video, we're going to be working on a project where we can create a virtual computer keyboard. It currently doesn't do anything. All it does is look pretty. But I'll teach you guys how to create this using a two-dimensional array. So let's get started. Think of a basic array as one-dimensional, as in it only contains a single row of elements, while a two-dimensional array can contain many rows of elements. Think of it as an array of arrays. So on your screen right now, I have a basic one-dimensional array. Well, we can turn this into a multi-dimensional array by adding more arrays to it, but there's a few changes that we have to make. So if this is going to be a two-dimensional array, we need two sets of straight brackets right next to the array name, and we're going to need to place the amount of rows and columns that we have in our multi-dimensional array into each of these straight brackets. So this is going to end up looking like some sort of grid or matrix instead of just a single row. So we are going to create multiple rows and separate each with a comma and surround our entire set of rows and columns with another set of curly braces. So all I'm going to do is just add another row. So we need another set of curly braces, and I'll put some more numbers in here. So 4, 5, 6, 7. I'm just going in order. We'll separate each array with a comma. Then we'll add another array. So we need another set of curly braces. And I'll type in 8, 9, 10, 11. All right. Now what we need to do is surround all these rows with its own set of curly braces. So we'll put that here and here. All right, so this might be difficult to see. What I like to do with 2D arrays is just to put each of these rows on a new line, just so it's easier to see and work with. Okay, so what you see now is that this is starting to look like some sort of grid, which is kind of the point of a two-dimensional array. So there's rows and columns to this. With the first set of straight brackets, we're going to place the amount of rows that we have, which is 1, 2, 3. So we're going to place 3 here. And this set of straight brackets is for the columns, and we have 1, 2, 3, 4. So we'll place 4 here. And that, ladies and gentlemen, is a two-dimensional array. Now, if you ever want to determine how many elements that you have in your 2D array, just multiply the amount of rows by the amount of columns that you have. So in this example, we have 3 rows times 4 columns, so that's 12 elements. So here we have 12, but remember that we start with 0 though, so it's going to be the numbers 0 through 11. Let's say that you want to work with or display one of these elements in the two-dimensional array. You'll need to retrieve that specific element. So it's going to be very similar to a one-dimensional array, but there's one extra step. So let's say that we just want to display one of these elements, so we'll just see out, then we need to type in the name of the array. So for my example, the array name is numbers, but we need 2 sets of straight brackets. We're going to place the row number here and the column number here of what we want to retrieve. So let's say that we want to retrieve this number 6. So we need to find out which row that it's in. And remember that we start with 0. So this is row number 0, and this is row number 1. So we're going to place 1 here. And then let's count the columns. So this is column number 0, column number 1, column number 2. So we'll place 2 here because we want this 6. And that's pretty much it. Let's run this, just to prove that I'm not a liar. Yep, here's our number 6. All right, here's an exercise for you. What do we place here for the rows and columns if we want to retrieve this number 11? Take a moment to figure it out. Yep, that's right. We're going to place 2 here, and then we're going to place the number 3. Let's test this out. Yep, there's our number 11. So let's say that you want to display all the elements of this array. Well, one easy way to do that is to use a nested loop. We'll have a outer loop that's in charge of the row that we're on, and an inner loop that's in charge of the columns. So for the statements for the outer loop, this is what we'll write. So usually you can write int I and set this equal to 0, right? We could do that, but I think for this demonstration, I'm actually going to rename I to row, all right? And then we're going to continue this while our row is less than the amount of rows that we have, which is 3. And then we're just going to increment our row by 1. And it's going to be basically the same thing for the columns. So we can say int column equals 0. We'll continue this column as long as column is less than the amount of columns that we have, which is 4. And then we're going to increment our column by 1. So within the inner for loop, what we'll type is cout, and we're just going to display our array numbers at the index of row as well as the index of column. And then inside the outer loop, we'll just want to move down to the next line. We can easily just do that with cout endl. And before we run this, I'm just going to add a space after each of these elements, just so everything's lined up nicely. Okay, let's run this. Yeah, and here is our two-dimensional array. It got kind of funky with these 2-digit numbers, but you can still see that it's a grid of some sort, a matrix of rows and columns that contains values. So that's the basics of two-dimensional arrays. If you would like to continue, we're going to work on a project where we create a virtual keyboard, kind of like the keyboard that's in front of your computer right now, assuming you're not on a mobile device. So if you want to continue, let's work on that project. Well, welcome back. So for this project, we're going to create a virtual computer keyboard. Maybe not the entire thing, but we'll just include maybe the numbers and the letters and some of the other special characters. And then afterwards, if you want to go crazy and add like an escape button, a backspace button, enter, shift, you could do so, but we'll just keep it simple for now, then you can go crazy afterwards. So let's begin by making a 2D array of maybe characters. So we'll make this of the char data type. And let's call this 2D array maybe keyboard. And then we need 2 sets of straight brackets. And we're going to set this equal to then all of the keys that we want to add to this keyboard. So I'm just going to stick with the numbers 1 through 0, well, 1 through 9 and 0. And then the first 3 rows of letters, so that's Q, W, E, R, T, Y, so on and so forth, all the way until the last row of letters. So I'm actually going to fast forward this video because it's going to take a lot of time to actually enter in all these individual characters. So feel free to pause the video. Otherwise, I should have all of this code completed and posted in the comments down below. So you can always copy this portion of the 2D array if you don't feel like typing this by hand. So I'm just going to fast forward the video until the point in time where I already type out all of these individual characters, and then I'll walk you through it.
A few moments later.
All right, well, welcome back again. So here is our two-dimensional array of characters. The first row is the numbers, then we have QWERTY, blah, 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 blah. The second row is ASDF, blah, 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 then ZXCV, and then we had some extra space, so I just added a few special characters here. All right, so then with the straight brackets, we need to list the amount of rows and columns that we have. So we have 4 rows. We're going to place the number 4 within the first set of straight brackets, and we have 10 columns, so we're going to place 10 here. So this is now our 2D array. Now let's say that we want to display this. We're going to use a nested loop to do this, kind of like what we did before. So we need an outer loop for the rows and an inner loop for the columns. So what we'll type in here is maybe int. Then let's go with rows again. So int row. Then we'll continue this as long as row is less than the amount of rows that we have. So we can put 4 here. All right. And then we'll increment our row. And we'll do the same thing, but with columns. So int column equals 0. Then column is less than 10. All right. And then column plus plus. And then we are going to display each of these characters. So we will see out our keyboard at whatever our row is, as well as our column. And then we'll just add a space between each of these characters when we display them. All right, and then we just need to move down to the next line. So we'll place that within the outer for loop. So we'll just cout endl. Okay, we should be good then. Let's run this. Yep, and here is our virtual keyboard. So someday, if you ever learn about graphics for C++, you could easily replace all of these individual characters with labeled buttons, and then you can click on each of these buttons to actually enter in a character or letter. So that would be really useful then one day. So basically, a 2D array can be used to display like a grid or matrix of information, whether it's like a table, a chart, a grid. A 2D array is pretty useful because you can organize it in rows and columns. So that's basically how a 2D array works. If you would like a copy of all the code that we worked on, I'll post it in the comments down below. And if you're looking for additional practice, why don't you post a program that you worked on that involves a 2D array? But yeah, that is how 2D arrays work in C++. Hey, how's it going, everybody? It's Bro here, hope you're doing well, and in this video we're going to get into object-oriented programming in C++, so let's get into it. Hey everyone, so for this part of the series we're going to get into object-oriented programming. So we need to distinguish first the differences between classes and objects. So look around you right now wherever you're sitting or standing. So you are currently surrounded by different objects. For example, I have a mic in front of me, I have a mouse, I have a cell phone, and I have a PlayStation 4 controller next to me. So in programming, we can actually create objects that mimic these things, and it's kind of like it's a new data type. So I could create, for example, a PlayStation 4 controller that has some qualities and it can perform something. Otherwise, I can create a cell phone object and it can do certain things. So we can actually create a class that serves as a blueprint for the different characteristics of an object and what kinds of actions that they can perform. So let's create a new class and we'll make some human objects. So we're going to create a new class before our main method. So to create a new class, just type in class and you need a name for this class. So if we're going to create human objects, we can call this class human. The second step is that we'll want the members of this class to be publicly accessible because normally we don't have access to whatever's in this class outside of this class. So we're just going to type the word public, and this is a access modifier. Now we can actually assign some variables that all humans should have. So what characteristics of humans come to mind? So I'm thinking humans typically have names, at least that I'm aware of. Let's make that singular though. They have an age, and maybe a weight. So we'll have a string variable named name, integer named age, and a double variable named weight. So these are kind of like nouns. They're variables that are acting as the characteristics of what all humans should have. Now humans can also have like functions. So what kinds of actions can humans perform? So for example, one that comes to mind is eat. So we can create a eat function for humans. So maybe if we call this function, we'll just say, this person is eating. Then we'll just end the line. Let's add a few others here. So maybe a drink function. This person is drinking and sleeping. So void sleep, this person is sleeping. Alright, so we have finished making this class. A class is a blueprint for what characteristics and functions that an object should have. Now we can actually instantiate an object. That's a fancy term for creating an object. So if we want to create our first human, we'll type in the name of the class, so it's human, and then we need a unique name for this specific human. I'll creatively call this one human1. Now with our object human1, it's kind of like the variable name, except that within human1 there is a name, an age, and a weight variable, and we'll still need to assign these some values. And when we instantiate this object, this is kind of like the data type. You know, with variables, we usually list the data type before the variable name. Well, it's kind of the same principle here. We're listing the data type of what object we want. We want a human, not a car, not a bicycle, a human, and we're going to call it human1. So we can actually assign these variables that all humans have. So if we want to assign human1 some values to its variables, we'll type in the name of our object. So human1 dot, and let's give this human a name. And let's give him a name of Rick. All right, so then this human now has the name Rick. We can also give him an age. So human1 dot age, and let's say he's 65 years old. There we go. I don't think we'll need to assign a weight. I think you get the idea. So let's actually display these just to test it. So we'll see out human1's dot age, and then end line, and we will do the same thing for name. Human1 dot name. So let's try this. Yep, Rick is 65 years old. Now we can create another human, so let's create human2. So we need to list the data type, so it's a human basically, and then we'll call this one human2. And let's give human2 a name and an age, so human2 dot name equals Morty. And let's give human2 an age, perhaps 16. All right, so let's display human2's age and name, but I'm going to flip these because they're bothering me because they're out of order. Okay, let's try this now. So human2's name is Morty, and he has an age of 16 years old. Now we can actually perform one of the functions within a class, so let's have Rick use the drink function that he has access to. So if you want to use a function that belongs to a class or an object, just type in the name of the object that you want to perform that function. So we could say human1, and we want human1 to use its drink function. So let's try this now. Yep, this person is drinking. So let's create one more human. So we list the data type, human, and we will call this specific human, human3. And we want to give him a name and an age. So we'll type in the name of human3 dot name is equal to, let's call him Jerry. And we'll give Jerry an age. So human3 dot age equals perhaps 45. All right, now we have three humans, Rick, Morty, and Jerry, and they all have a eat function, drink function, and sleep function. But there's one thing if we try this though. Since these functions all have basically the same syntax, we can't differentiate like who's performing which function. So I'll give you an example. Let's have human1, which is Rick, use his drink function. We'll have human2, that is Morty, use his sleep function. And then we'll have human3 use its eat function. So if we were to display these, it's all going to look like the same thing. We can't differentiate who's calling this specific function. So what we can actually do is that with these strings within our functions, we can actually replace this person with the actual name of the object that is calling this function. So I'm going to take out this person, and what we're going to place here, but let me just add these insertion operators. So we're going to replace this person with this dash greater than sign and then name. So this is going to be replaced with the name variable of whatever object is calling this function. So we're going to take this name, and place it here. And let's try it now. There, Rick is drinking, Morty is sleeping, and Jerry is eating. Likewise, you can do this with other variables too, like you can say this age or this weight, but you know, this name works for this example. All right, so I think that's the basics of object-oriented programming. An object is an instance of a class. An object usually has some sort of attributes like values and variables that act like nouns that describe the object itself, and they can usually perform some sort of action. So for example, our humans, they have a name, age, and weight. They can eat, drink, and sleep. And a class is like the blueprint of what attributes and functions that all humans, or whatever object you're dealing with, can perform. So that's the very basics of object-oriented programming in C++. I'll post all of this code in the comments down below if you'd like a copy for yourself. If you're looking for additional practice, why don't you create your own class and then post it in the comments down below as well if you'd like to share it. But yeah, that's the basics of object-oriented programming in C++. Hey, how's it going everybody? It's your bro here, hope you're doing well, and in this video we're going to be discussing constructors in C++, so let's get into it. Hey everyone, so we're going to be discussing constructors. A constructor is a special function that is automatically called when an object is instantiated. I needed to write that down because I wouldn't remember the definition. So it's useful for assigning arguments to variables whenever we instantiate an object. So based on the last lesson with object-oriented programming, we created 3 humans. Well, we have 2 now, we lost Jerry. So we have Rick and we have Morty. So you can see that it's a lot of work to manually assign all of these values to variables. But one thing we can do is that we can create a constructor to take care of that for us. So a constructor is automatically called anytime you instantiate an object of that class. So if we want to create a new constructor for our human class, this is what we're going to type. So after all of these variable declarations, what we're going to type is the name of our class. So we're going to type human, then a set of parentheses, and then a set of curly braces. So this is almost identical to a function, but we don't need to list a return type. Now we can actually set up parameters for this constructor. So for example, we could pass in some of these values that we're assigning to these variables as arguments now, and we don't have to do this by hand. So we can actually send in the name, an age, and a weight. So let's do this here next to each of these object names. So we're going to set up some parentheses, and then we're going to pass in some arguments. So we're going to send in the name Rick, and the age of 65, and then a weight of 80 kilograms. So let's do the same thing for Morty then. So we're going to change the name, send in the age, and a weight in kilograms. All right, so we no longer actually need these because we're going to take care of this in the constructor. So within the constructor, we need to set up parameters. So we're going to need to set up a string variable that's going to function as a name, an integer that's going to function as an age, and a double value that will function as a weight. All right, you can see that all the red underline went away now. Now we can actually assign some of these values to each of these individual objects then. So this is what we're going to type. Now this is what we're going to type. The keyword this dash greater than sign name equals name. So this name is whatever we receive as an argument. So we're going to follow a similar pattern for the age and the weight. So this age equals age, and this weight equals weight. So these are the values that we're actually receiving, and we're assigning these to the variables of the object that is currently using this constructor. So if we're instantiating the human1 object, we're assigning all of these values to the variables of human1. And if human2 is using this constructor, we're assigning all of these values to human2's variables. So basically, replace this word with the variable of whatever object is actually using this constructor. So that's a good way of thinking of this. So this allows us to actually reuse these statements. Before, we had to type these out by hand, and it's not too bad if we only have 2 objects, but imagine if we had hundreds. We'd be here all day then. So we can simply just keep on reusing this code then. Now let's display all of human1's variables just to prove that I'm not a liar. So we'll see out human1's name, then we'll end line, and let's do the same thing for his age and his weight. So human1 dot age and human1 dot weight. I think I'll add maybe years old after the age, and kilograms after the weight. So KGS. All right, let's try it. Yep, Rick is 65 years old and he weighs 80 kilograms. Now let's replace this with human 2. Yep, Morty is 16 years old and is 60 kilograms. So now if we ever create a new object, we can just pass in some arguments if we want to assign some values right away. So if we want to create human 3, and human 3 is Jerry, and he will be 45 years old and he will weigh 85 kilograms. So whenever we instantiate a new object, we can just pass in some values to assign to this object's variables right away then. So let's display all of human 3's variables at this point, and we'll try it out. Yep, Jerry is 45 years old and weighs 85 kilograms. Okay guys, there's one thing I should mention before you go. So with C++, it is possible to place a constructor outside of its given class, and you can do this with something called a scope resolution operator. It's basically these 2 colon symbols. So within a class, you can simply have just the constructor declaration like this, and then we can place the rest of the code outside of the class. So what you might see is the name of the class followed by the scope resolution operator, followed by the name of the class again, and then like the rest of the code here. So this would also be valid, and let's actually try this. So you can see that it works just fine. So that's really the basics of constructors. It's a special function that is automatically called when an object is instantiated, and a good use for this is assigning arguments to variables right away. So instead of assigning all these values by hand, we can just pass them to a constructor, and the constructor can take care of it for us. So that's basically what a constructor is. So if you'd like a copy of all the code that we worked on, I'll post this in the comments down below. And your homework for today is to post a constructor in the comments. But yeah, that is how constructors work in C++. Hey, how's it going everybody? It's Bro here, hope you're doing well, and in this video we're going to be discussing overloaded constructors in C++, and at the end of this video we're going to be creating a project where we're going to be ordering some pizzas. So, let's get into it. Hey everyone, so this video is dedicated to overloaded constructors, and just as a quick reminder, a constructor is defined as a special function that is automatically called when an object is instantiated, and this is useful for assigning arguments to variables right away when we create an object of some sort. So a good example of this would be pizza objects. Pizzas have varying amounts of ingredients, so I have, for example, 4 different pizza constructors here. And this is legal. You can reuse the same constructor name as long as there are different sets of parameters set up. So for the first constructor, I have 4 string parameters set up: a bread, a sauce, a cheese, and a topping. The third just has 3, a bread, a sauce, and a cheese. Then 2, a bread and a sauce, and lastly, just a bread. So we can create pizza objects, and we will use a matching constructor when we instantiate an object, depending on how many ingredients we send our constructor. So let's actually work on a program where we're going to construct some pizzas and order them. So to begin, let's create a pizza class. So class pizza, but make sure you spell it right, because I didn't. And then we'll want to make these members public so we can access them from our main method. So we'll create the first pizza constructor. Honestly, I shouldn't have deleted everything, but too late, I already did. So we'll pass in a string bread, string sauce, string cheese, and string topping. And then what we'll do is just assign these values right away. So this bread equals whatever bread we receive, and we'll do the same thing for sauce, cheese, and topping. All right. Now we'll actually want to declare these variables. So we're going to do that before our constructors. So string bread, but we're not going to assign them. String sauce, string cheese, and string topping. All right, so this is our first constructor, but I misspelled sauce. There. So this is our first constructor. We can actually create another constructor with different parameters. So I'm just going to copy this and paste it. We're going to get rid of our topping. And then we'll get rid of this line too. We'll copy this and make another constructor. So this one's just going to be bread and sauce. And the last one is just bread. Okay, we have our constructors made up. So let's create an order function. Maybe we'll call this order pizza. And this doesn't return anything, so we'll put void here. All right, let me think of something. Okay, I thought of an idea. We're going to display a message that says, here is your, then list all of the ingredients that are not empty, and then just add the word pizza at the end. Kind of like somebody's delivering it to us, or we're delivering it to somebody. So within our order pizza function here, we will just see out, here is your, and then the next step is we're going to check to see if our bread is not empty. So if bread.empty function, but we're going to put the not logical operator here. So if our bread is not empty, what we'll do is see out whatever our bread variable is, and then maybe we'll just add a dash after it. Now we're going to do the same thing for sauce, then cheese, and then, what was it, topping at the end? Yeah. So if sauce is not empty, we'll display whatever the sauce is. Same thing for cheese. And lastly, topping. All right, and then we'll just add the word pizza at the end. So see out pizza. But maybe I should turn this last one into a space. Then end of line. Okay, we're good to go then. Let's construct some pizza objects. Now, to instantiate an object, we first need to list the class as the data type. So this is going to be a pizza object, and you can see that we have it right here for the class name. So next we need a name for this pizza. Let's call this maybe first underscore pizza. And then we can pass in some ingredients as arguments. So let's pass in a type of bread. So maybe thick crust. And let's pass in a sauce. I'm not sure what the standard sauce pizza uses. It's some sort of red sauce. It's a mystery to many. And then what about mozzarella? I'm probably misspelling that. I always do. And then, you know what? That's it. Let's just stick with these three ingredients. And then we'll call the order pizza function. So we'll type in the name of our pizza, first underscore pizza, and then we will order pizza. And let's run this. Okay, here is your thick crust red sauce mozzarella pizza. Now let's create a second pizza with different ingredients now. So pizza, we'll call this second pizza. And I want flat bread and, I don't know, Alfredo. And that's it. And then we will order our second pizza. So second underscore pizza dot order pizza function. Here is your flatbread Alfredo pizza. Now that's one of the benefits of using overloaded constructors, is that they allow us to instantiate different objects with varying arguments, and this works great for constructing pizza objects because pizzas can have varying different types or amounts of ingredients depending on the pizza. So for the first pizza, this has 3 arguments and the second one has 2. Now, if we were to take these out and we only had this one constructor that needed 4 ingredients, well, this actually wouldn't work anymore, because if we were to construct a pizza, we need at least 4 ingredients. But if we put these back in, we can have between 1 to 4 ingredients. But you can have more than this too. You could have a pizza constructor with 5 ingredients, 6 ingredients, so on and so forth. Well, that's the basics of overloaded constructors. So if you would like a copy of all the code here, I'll post this in the comments down below. If you're looking for additional practice, then your assignment is to create a set of overloaded constructors and then post it in the comments. But yeah, that is the basics of overloaded constructors in C++. Hey you. Yeah, I'm talking to you. If you learned something new, then you can help me help you in 3 easy steps by smashing that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro.